Hello YouTube, we are going to do the PTS Midterms of 2017 and 2019 today to prepare for the exam of tomorrow. Always fun. So I'm here in the Discord with like 30 people, and without further ado, let's get started. So first off, about the events A and B, it is known that the chance of B complement is 1/4, and A given that B is 1/2. Compute the probability of A and B. Well, this one is relatively straightforward. So we know that P of B complement is equal to 1/4. Why is my grass ball shitting the bed? There we go. Therefore, we know that the P of B is equal to 1 minus P of B's complement is equal to 3/4. Yep, so now we have the chance of PB and P of A given B, which is 1/2. And we know that the chance of PA given B times the chance of PB is equal to the chance of A
Cap.
cap? Oh yeah, cap,
Cap
because
goes
it's
up,
and.
cap goes down.
Yeah. And this is what we want to know. So basically it is just this probability times this probability. So 1/2 times 3/4 is 3/8, which is B. So I will write that down here as well. 1B. Okay. In Delft, 1/3 of the days have some rain. Assume Weer Online is correct 4/5 of the time. That is, the probability that Weer Online predicted rain given that it rains, and the probability that Weer Online has predicted it would not rain given that it doesn't rain is 4 out of 5. What is the chance that it rains given that rain was forecasted? Well, now we've got a bunch of text. I do not like text, so we're going to transform that into probabilities. So we have, let's say,
I do not like
A.
text goes into a text editor.
Hmm?
I do not like text goes into a text editor.
So let's see. A equals. The annoying thing is, if I do that here, you will see it like this. But yeah, I'm just going to assume you guys know what I mean. Um, hmm. I'm not sure whether I would need 2 or 3 or a 4
No,
thing here.
you only need 2, the chance that it rains, and
And
so A is the probability that it rains, and B is the probability that it predicts the right weather.
predicts the right weather.
No, that it predicts rain in this case. If
Yeah, this seems more correct. Yeah.
yeah,
So we know
and
that P of let's see, A given B is equal to P of A complement given B's complement is equal to 4/5.
they
Yeah, so we know that the chance if it rains. Oh wait, other way around. You're right.
no, yeah,
So we know the chance that
rains and
it predicted rain given that it rains. So it
it's
predicted rain given that it rains, and is equal to the chance that it doesn't rain, or that it predicts no rain given that it doesn't rain, is equal to 4/5. And we want to know the chance that it rains given that rain was forecasted. Oh. So this is what we want to know. And now can I put the A and B in code blocks so it treats it as math?
Yeah, like this thing. If
And
I
IT range.
the thing is that
Shanty.
if I don't do that, then it will put it here, and then
Oh yeah, yeah. That's horrible.
Yeah, no, I was about to say. So that's why I'm doing it in here. Like it's harder to read, but it's actually all in one place.
Yeah.
Let's see. So
Use camel case.
Hmm?
Use camel case. That might make it a bit more readable.
Yeah, okay.
Use a slash text for that.
Yeah, slash text might work.
Yeah. Either way, it's not too big of a deal.
Yeah.
So we know that P of B mid A is actually equal to P of B gap A times P of A. Let me see if
Over.
this is actually correct.
Over.
Yeah, okay, it's over. Yep, that makes sense. Alright, so we know this probability. And this is equal to 4 over 5. And we also know that B's complement mid A's complement is equal to the fraction of B's complement gap A complement over P A's complement. Did I put my brackets correctly? No, I didn't. Okay, is equal to 4 over 5. Okay, so now we put what we know from here into more more of a relativation. Let's see. What we can do is we can turn this A's complement into P of A by subtracting 1 from it. So I can say that this is actually equal to 1 minus P of A. Let's see, we have a P of A here and a P of A here, and these are both equal to each other. However, I'm not too sure how this will help us.
I would say multiply out the bottom part, so it's just multiply. So it's
Like cross multiply these two.
yeah, just I would say start off by
Notice that the first sentence says 1/3 of the days has some rain. Maybe use that as the chance of A.
yeah, chance of BA is 1/3 apparently then.
Hmm?
BA is 1/3. It's right there in the question
Wait,
at
what?
the start.
First sentence.
In the first sentence.
Oh.
That
If
makes it a
nothing
bit easier,
helps,
doesn't it?
read the question. 1/3 of the days have some rain. And again, our A is the chance it rains. So PA is 1 over 3. Okay, that helps. That now we can also do a lot more. So we
Yeah.
actually know that this is actually the chance of P 1 minus PA is equal to 2 over 3. But that's alright because that's just a constant. And the chance of PA is actually equal to 1 over 3. So now we know that this is equal to 4 over 5, which helps because then we can multiply both sides by 3, which will give us P of B and A.
Mm-hmm.
Actually, no, we have to multiply both sides by 1/3. Okay, yeah.
Yeah, yeah.
So therefore, yeah, we can say that following from from this line and this line, that P of B cap A, or actually because I can rearrange these, I'll say A cap B, A cap, is equal to 4 over 15. And again, that is because we multiply both sides here by 1 over 3.
A cap equals 0.131412.
And then we also have the chance of A's complement cap B's complement is equal to this one times that one, and that is, oh, it always freaks out when I don't write something for too long. So that was 2 over 3 times 4 over 5, that is 8 over 15. Recompile. I probably should have started my timer. I'm not a very smart man. So now we know the chance of A and B happening, and the chance of A's complement and B's complement happening.
And we have a chance of A as well.
We have a chance of A as well. Can we, from these two, collect the chance of...
What I would do
No.
is just start drawing.
That is very fair. You make a good point. So we'll bust out the paint.
Finally.
Yeah, it was way too long already.
It's been at least like 2 minutes.
So this is A.
Yeah.
This is B.
The entire outside
we
part
know-
is 8 over 15.
Let's see. We know this chance. Oh no, not that chance. We know this whole chance.
Yeah, I was about to say.
We know A and B happening. So that is this chance.
Yeah.
And what else do we know? We know
Then we can
not
get
A
B from
happening
them. That's all
and
we
not
need
B
to know.
happening. That is...
No, but you don't need the rest. You can get PB from PA and PA and B. Right, because PA plus PB is actually no.
Do
from
we know? Because
all of
we
these
don't know
things.
anything about this like this.
Well,
part
you
here.
do know that everything together is 1.
Yeah, okay.
So,
with this combined, we
A
do know
and-
everything. So
yeah.
we know that 1 minus. So let me. Yeah, okay, this makes sense as well. So let me document real quick. So we know that 1 minus P A's complement cap B's complement is actually
A union
P
B.
of A complement cap B's complement complement, and I'll recompile this so you guys can look at this a little more to see what this means. And then when we take the complement into the sign, we can apply De Morgan's law here, which will give us the chance of A or the chance of B.
Yeah, and then we can use to calculate.
Yeah,
this.
and that this we can use to
I would rather know what the value of that is.
yeah,
of
I
7 over
will.
15.
So that is equal to 1 minus this thing, which is equal to 7 over 15. Is that correct? 1 minus 8 over 15 is 7 over 15. Yeah, okay, and we want to know the chance of A given B, but for that we first need the chance of B. So to get the chance of B, we take this whole thing minus the chance of A plus the chance of A and B.
Yes.
So then, therefore, we say that P of B is equal to P of A cup B minus P of A plus P of A cap B. Is this correct? So we're saying here that it's everything minus this part plus this part. This seems correct. Yeah, and that makes sense because if we add P of A on both sides and subtract P of A cap B on both sides, then we get A or B is PB plus PA minus PA and B, which we
That's
know
the
is a formula. Yeah, that's the formula we know. So let's see, and then we can fill in the value for this. This is equal to so the A or B is 7 over 15. We know chance of A is 1 over 3. And we know the chance of A and B is 4 over 15. I'm going to write 1 over 3 as 5 over 15. And then we will get, let's see, so that's 7 minus 5 is 2 plus 4 is 6. So the chance of B is 6 over 15. Okay, so now we know the chance of B. And then to get the chance of B given A is equal to the chance of B.
A given B.
Sorry, A given B, my bad. Is the chance of B and A over B
Let me see if that is correct.
Yep.
Yes, okay. And we know
Yep.
both of these.
Was
So-
slightly misleading because I would write this down as P, A, and B, but yeah,
Mhm.
correct.
Yeah, A and B, B and A.
Yeah, same thing.
So this is basically equal to
4
a
over
fraction
15.
of. See, what would B and A? That's 4 over 15 over P of B, which is fraction of 6 over 15. There we go.
4 over 6, that's 2 over 3.
And we can multiply this by 15 on both sides, which is 4 over 6, which is 2 over 3. So the chance is equal to 0.6. Actually 0.67, but we'll let it slide this time.
This
2
one time.
is equal to,
I want
or
supposed to be a slide whistle.
2 E. I'm curious, how did they like get to 0.66 though? Because it's like obviously rounded to 0.67. Whatever.
Nah.
When rain is forecasted, AF takes her umbrella. When rain is not forecasted, she takes her the probability of 1 over 3.
Oh.
What is the probability that she takes her umbrella on a given day?
Seems simple
So
enough.
that is 3.
Uh,
So the expected value is 1 times probability that there's rain plus 1 over 3 times probability that there's no rain.
Wait, no, when the rain is not.
Oh wait,
When it's
when the rain is
forecasted,
forecasted, so it's B.
Yeah.
Yeah, I messed up my labeling of my variables now. But we know both of these, so this is just filling in 3 points.
Both of these nuts.
I said C. This should actually be 3. So let's see. We know P of B, which is over.
But it's not you're now calculating the expected value. You should be labeling it as the probability.
Yeah. Okay.
I mean,
Oh.
it's still correct because they're like two independent probabilities which add together. But
Yeah. Whatever. Probability
C,
umbrella is equal to whatever.
sure.
So this is 1 C dot. Let's see. The chance of B is equal to. Oh, so this is the chance of B, which is 6 over 15.
Yep.
Yep. Is frac 6 over 15 plus 1 over 3 C dot
9 over 15 is 3
9
over 15.
over 15 is equal to. Recompile.
3 over 15.
Oh, wait, what the fuck? What? Huh? Does it not? What? Why does it not like my fractions? Oh, I didn't put a space. Oh, that's a capital C? What the fuck?
Nice.
Sorry. Is equal to well, this is just 6 over 15 plus 3 over 15, which is 9 over 15. Which is 3 over 5.
0.
That's 0.6. Or, well, okay, it literally says at 3 over 5, so we can say that 3 is E. Oh.
We're now at 1/6 of the test. I really hope the rest of these points are fucking gratis as well.
Whoa, I want the rest of my 3 points as well.
Gip.
Yoink. Oh,
I've done this one.
okay. A coin is tossed 3 times. Consider the events. It's head for a first toss, tails for the second toss, heads on the third, all 3 outcomes the same, and exactly 1 head turns up. We can already say that A, B, and C are all independent by physical independence.
Yeah. Like then there's only one question, or then there's only like 1 or 2 left which are correct or which are remain.
Yeah.
A.
So
E,
we
and
have
F.
this one. And is there any else that mentions A, B, and AC? Yeah.
A, E, and F. Because A is also A, B, and AC.
Ah, yeah. So the question is, are A and D the same, and are A and E the same?
Yeah.
So let's see.
So
calculate
it's only
A.
about A and E and A and D.
Like A is heads and E has something to do with heads. So
Yeah, so this
I
is
feel like that isn't gonna be independent.
yeah, exactly. Yeah, so this
I
is
can
just
do the math. Just calculate what the chance for E is without knowing A and what the chance is while knowing A.
sure we can check. So we know the chance of for independence it's proved to say
It's
PA and E.
Isn't it given?
Hmm?
Isn't it PA given E is equal to PA and E? Or PA?
Isn't it this?
Oh, no, that could. Yeah, because that is the same. Because what I say is P, A and E divided by PE is PA. So if you multiply both sides by PE, you get the same. Yeah.
Oh my god, Yella, it says here ape. This is a sign about GME.
Well,
Alright, so let's see. Well, let's calculate the chance. The chance of the first one being heads is 1/2. The chance of exactly one head turns up. Well, we can have a look at that. Actually, in that case, let me gezellig. Let me actually draw it out. Oh, that's portal code. So we have heads, heads, tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails.
Tenminste, houd bij tot.
So the chance we want to know is heads on the first off, which is 1/2, and exactly one head turns up. So that is 1, 2, 3. Is that
I
correct?
already told you this.
Hmm?
There's 3 coins. The chance of exactly one heads is like 3.
It's 3.
3 out of 8.
Yeah. So yeah, so we have this times frac
Crap.
3/8. And now the question is the left side equal to the right side? And this again, this would just be like 3/16.
Then we have to calculate PA and E.
Frac 3/16.
Well, we already know PA and E is not going to be there because it's only like 8 possibilities. So, yeah, no, that's never going to be true.
That's true, yeah.
Then you would need 1.5 things which are true.
Yeah.
And
Because like the probability of A and E means that A and E is a certain number out of our all equally likely sample space of 8. So this can just be an integer number over 8.
yeah, exactly.
So we know that A and E are is this E or D? E. This is A and E are not independent. Cool. And then let's figure it out for A and D. So P A cap D.
Well, if you already know this, you know it's F because if you know it's not A and E, then E and A already fall off.
Oh yeah. Yeah, okay, that makes sense.
All of them have A and E. So if you just disprove A and E, then F is the only one that remains.
So we have 4 F.
Is this clear for everyone? Because we did a very. Let's say we used abstract reasoning.
No, but it makes sense, right?
Yeah, I think it does. But I'm just checking if it does for everyone else.
Okay.
No, wait, I don't get the part where you say that you divide by a big number. Wait, what?
Okay, so we know that the right hand of this probability is equal to 3/16.
Yeah, okay.
The left side of this probability is so like we have this 8 the sample space of 8. From these 8, we want to take the cases where it is heads for first thought and all 3 outcomes are the same. So that is
So that's
some
one
number out of 8. I don't even know which number or care which number. It's probably 1, but it's some number out of 8. But you cannot get to 3/16 by having an integer number over 8.
Yeah, because you would need 1.5 possibilities which are correct, and that's
Yeah.
not possible.
Like you cannot say 1/2 of these 8 possibilities are correct.
Oh, wait, I get it. Okay.
Yeah.
Good.
It is very abstract reasoning. All you need, like, there's also another way to solve this, which is just looking at the cases in which this is true,
which is only
One.
yeah.
Yeah,
That feels
case number 4.
Okay, yes, I
Um,
get it. Thank you.
You're welcome. Okay, 4, next one. For which random variable below would be appropriate to assume a discrete uniform distribution? Let x1 be the number of tosses of a coin necessary to get heads for the first time.
That sounds very
No.
much like something else we had. I think Poisson or something.
You know, you do make a good point. Let's actually, grab the formula sheet.
That one is geometric.
Also very possible. I do not
Yeah,
know.
It
which
is
physical
geometric.
thing
You just
corresponds
didn't know
to
the
which.
name.
I knew it
Discrete-
corresponds to something else. I do not know which
for,
one.
For discrete, it would be geometric.
Okay. Let's
For
say.
uniform, that would be Poisson type question.
Oh, I'm not completely dumb. Hey.
So no, that's the wrong one. Where's my this one?
Yeah,
Okay.
I probably arranged that it's geometric just from looking at the calculation because
Not
all the like for the what I like about the discrete ones is everything is binomial, except for uniform. The uniform is just it's uniform. You know what it is, and the rest is just fucking binomial, but n is 1, and it's the
But
one
with
at
a
the end.
twist.
And the last one is just what the fuck are you doing?
Yeah. Gonna be honest, I don't completely understand Poisson, but we'll see.
Okay, basically, Poisson is very simple. You know, the bus will arrive soon. It's probably not going to arrive.
Amund, you're really fucking soft. I do not understand a single word you're saying. I'm sorry. Is that
Are you
just
in the
me?
car again?
Far, so.
Yeah, he's in his car. He's always in his car.
Okay, we'll get back to this. I first wanna.
He's saying basically, for example, probably that so the train arrives every. Let's just say the train has a like distribution of like Poisson like one every 2 trains every hour at a station. There is a probability that 3 trains arrive in an hour, but it's much lower than 2, and there's a probability that 1 train will arrive in an hour, but it's much lower than 2. Then that 2 arrives.
But the
Something
2
like
is the most likely value.
Yeah.
And then it's uniform, so you can have 2.7 trains there.
Yeah.
But
Yeah.
you can have 2.7
But
trains
you
per
can
hour,
have
but the
that.
input is like a whole number, isn't it?
No, you could have a Poisson distribution like 5.7 trains per hour.
Yeah, but like the mu is 5.7, but the x has to be a whole number because I believe they said that in the formula sheet. Can you go to the formula sheet, Joe?
No.
No.
Poisson for k is 1, 2, etc.
Oh,
Yeah, because it's discrete, right?
yeah.
The cases we use it might be, but it can be
Yeah.
done.
Either way, let's continue.
Yeah, because we're applying like the mu is like the expectation, but we are trying to find like you can't actually have 2.5 trains arrive.
Yeah.
You can't have half a train arrive.
Exactly. So.
I mean, you
The actual
can, but
amount,
that would be called an accident.
or a very precise timing.
Yeah, like you stop the train like halfway in the station. But
Yeah.
that would still mean that the train has arrived because, like, again, like.
Let's stop talking about the
Yeah.
formalities of trains and go into question. Let
It's
x1
the
be the
same
number of
thing
tosses
with-
of a coin necessary to get heads for the first time. Again, that is just the geometric distribution because you need to have 1 head and k minus 1 tails.
Yeah.
Let's see, second one. Let x2 be the birthday of a randomly chosen person.
Yes.
Yeah, that's
like
uniform.
I don't think if I could make something more uniform random.
Yeah, like this is as uniform as it gets. The outcome of a roll of a die, also uniform. I mean, a discrete uniform?
Yeah, but it's
Yeah,
discrete.
so for example, day of birth and dice are like, for dice you can have everything from 1 to 6, but only 1, 2, 3, 4, 5, 6.
Yeah, okay.
Day of
fair.
birth you can have anything from 1 to 166, but only 366, but only from that to
Yeah,
that.
so discrete uniform distribution is just
Yeah.
a uniform distribution with only discrete values. Okay,
Yeah,
cool.
exactly.
Just
Um,
imagine you could
be the
just
number
add
of
loads
heads
of
obtained in 3 tosses of a coin. No, that's the binomial.
Yeah,
So it's basically C.
It's basically C.
Wait, what the fuck?
I like the ones where
What
you just
the
have this thing.
fuck?
What the fuck?
What?
What
Beans.
the
What
fuck?
the fuck?
what the fuck now?
Let me refresh my page. That will probably help.
What the
Who
frick?
here watches Bird?
There we go. 5C.
Bird is awesome.
Beans. What the fuck? Okay,
What is it a lowercase c?
don't worry. I know you're autistic. Here's a capital C. Okay.
The world would have ended otherwise.
I'm putting
Okay.
beans in Vichy
Good.
channel.
Suppose you play the roulette wheel during your visit to Las Vegas. The roulette wheel has 38 possible combinations: 0, 0, 0, and 1 through 36. Half of the number from 1 to 36 are red, half are black. Suppose you bet $1 on black. Then you win $1 if the ball stops in red, and lose $1 otherwise. What is the expected value of a winning?
Of
We
your
can take
winning.
the expected value of a random variable x. I will say x is the variable from this thing. Is equal to the chance that we win times the money that we win. The money that we win is 1 plus the chance that we lose times the money that we lose, which is -1. So I'm gonna say this here -1.
Well, that would be a profit. They say are winnings.
You win $1 and lose $1 otherwise.
Yeah.
I'm gonna say that it's
Yeah.
Yeah,
the where you can go negative.
This is horribly praised.
No,
Let's
I think this is alright. So this is what we have.
No text, only numbers.
I think this is good
Oh.
enough. So we have when we take away the ones, we get the expected value is the chance of winning minus the chance of losing. So the chance of winning is the
18 out of 38.
no, or out of 38, yes. So
Yes.
there is a little caveat. I had multiple people ask questions about this one before, because they were like, "What? Why is it not 18 out of 36?" But it's actually out of 38 because you have the 0 and the 0, 0 as well.
Well, now we know that these guys are using the American.
Hmm.
Pretty sure this one's the American version. British only has 0.
There's probably some different version of roulette. I don't really care about that for now. Right now,
I mean, at least it tells you what kind of roulette it is.
yeah. So the answer for this one would be -2 over 38.
Imagine
And -2 over 38,
no-
that's practically -2 over 40, so it's minus 0.05.
Yeah. Imagine if they just
Scientific
give-
explanation.
Yeah. Imagine if they just give you just say you have a roulette wheel. The chance that you win is that, the chance that you lose is that, but don't give you if you win you earn that, if you lose that, but they don't give you the probability of landing on them because they assume you know what a roulette wheel is. That would be horrible.
That would be horrible because we all know that the game's rigged.
Fun
Yeah.
fact: you can always make money from roulette by having a game which gives you double your money if you win and 0 if you lose, and the chance is 50-50. By every time you lose, doubling your input, and once you win, you will gain all the money that you lost plus 1 So you can be betting
true.
millions.
No,
Euro
but
bet.
roulette,
Right there. That is not how that works.
roulette
It is
is
how that works.
mathematically impossible.
That's
to win.
absolutely not how that works.
It is how that
Roulette
works.
is
I'll,
You can
I'll,
beat
I'll
math
send
how
you,
that
I'll
works.
send you a
You'll make-
number file video on it,
You'll
bitch.
make money in such a small increment that even though you're technically making money each time,
You said you made money, and that's all that matters.
this works if you have infinite money and only if you have infinite money. Because eventually it's double or nothing each time. Eventually you'll lose all your money to make like a 0.1% profit. Eventually the risk, it's the same amount each time. It's rigged against you. If you have a 16 out of 38 chance, 18 out of 38 chance of winning.
To be fair, Yella said given a 50-50 chance.
Yeah.
So. Either way, let's stop discussing the formalities of a fucking roulette wheel and go with the questions. Bit is here.
Look
Let
at VC
X-
channel.
Hmm?
I set the video on the strategy in VC channel. It's from
Let
number
X-
file. You know number file.
Let X be
Everybody
the
loves number file.
shut the fuck up. Let X be the lifetime of your mobile phone in months.
Angry
With-
user.
0.
um, with fx 10 over x squared, x greater than 10. And the cumulative distribution function, CDF, for x bigger than 10 is given by. And basically what they're saying here is we have f of x is equal to fraction 10 over x squared for x is greater than 10. What they are asking is the cumulative distribution function, which is practically the capital F of x. And I should actually say here, like
integration time, and then figuring out what c is by applying that at infinity it's 1 and at negative infinity it's 0. Whoop whoop.
Whoop, whoop. I mean, no, like the total area in one.
Yeah. So yeah.
Okay, so this is the integral from
wedge SMH.
minus infinity infinity to positive infinity.
I mean, Jurgen, you say that we were instead looking at the total area, but inputting infinity is looking at the total area since it's from negative infinity.
One. That will always give 1 for any distribution function.
Exactly, but we are given 5. No, we are
Oh.
because we're giving like 6 functions, and some of these don't even have like because there's an f.
Yeah. Okay. Fair. Not only that, but like, indeed for this function for a capital F, add minus infinity at 0 and it's positive infinity at 1. You were right. I didn't think about that.
Yeah.
That makes sense.
But we're not doing the infinity part. Just without the infinity, it's correct.
Yep.
Yeah. So we can take this 10 up here out front, and then we have 1 over x squared.
AKA
And well, that's the same as
-2.
saying x to the power of minus 2. Okay. Again, this is assuming for x bigger than 10, so we can take the lower bound as x is 10 and the upper bound as x equals to infinity.
Once again, we're not looking at the bound. We don't want the bounds.
Well, okay, yeah, it's from lower bound to a.
No,
Or-
but yeah. I
Yeah.
suppose. Yeah.
We're looking for a function which satisfies this.
Yes. Then we can say this is 10 times the integral. Well, we can actually just evaluate this. So this will be 1 over minus 3 times x to the power of minus 3. Evaluated from
Did you add
10.
1 to -2, making it -1?
Fuck, you're right. I always fuck that up when we're working with
differentiating.
negative numbers.
Mm-hmm.
Negative numbers.
Okay, then we have from 10 to a. I will also take this minus sign out of the bracket. So that will leave us just with x with 1 over x. Filling this in gives. Let me actually make a new line for this. No, it's not. So we have minus 10 times. It's upper bound minus lower bound, so we have 1 over a minus 1 over 10 plus c again.
Well, no, we don't care about C. We don't have C.
Yeah, because you.
Oh well, yeah,
from
the c
Yeah,
like
we have it bounded.
it's a
bounded.
so the c is like plus c minus c.
Mm-hmm.
So constant goes away.
So what?
Yeah,
minus
filling
10
this in,
over
then we get is equal to minus 10 over a plus
-1.
1.
Yes, you're right. Sorry.
Okay.
So then we get a minus 10 divided by a, which means x minus 10 divided by x, which means b.
Yeah.
Why is it taking so long to compile?
Juggernaut!
Yep. Then we multiply by a on both sides, and that will give us
A minus 10 over a.
And
or yeah, we
which
can
is
do that.
equal to B.
That's yeah.
because we know this is fa, we get that a can be replaced by x because we want to know fx.
Yeah,
we
yeah.
used
The
a as
reason I
a
just used a here because we are working with in
we already had
terms of
that.
x here, so yeah. So we can say that this is equal to we can say that this is equal to 7c. That's the
Seven.
6.
I mean, 6 is 3 as well, to be fairly honest.
Yeah, I mean, I was correct.
Mm-hmm.
Assume you have 6 similar keys on your keychain and exactly 1 opens the door. Imagine after each try you drop your key on the ground, so you're no longer you are unfortunately handicapped. So you no longer know which keys you have just tried. What is
Sadly, just before unlocking the door, you ate a whole stick of butter. Your fingers are still greasy.
Ooh, yeah. What are the expected numbers of keys you have to try before opening the door? So let's see. We have 6 similar keys. The chance of it working is 1/6 every time.
Wasn't there a distribution which was
Yeah, I was
like,
about to
hey,
say this is a
many
distribution. So I guess this is just a geometric one. So you fail k minus 1 times, and then you pass.
and the expected value is 1 over p.
Yeah, 1 over p, and the chance is 1 over 6. So the answer is just 6.
Maths.
Wait,
I
the
could-
answer sheet says that 7 is B.
It is b. We're just too dumb to fill in stuff correctly.
Oh wait, okay, never mind.
Oh yeah, it is. Like
But you guys were yelling at me that it's C. Fuck you.
Well, no, we were yelling at you that it's 7.
What? So
You
Okay.
filled in 6. We were like 7.
yeah, but you guys were telling me that it was C before that.
No, we were telling you to add c, and we were wrong.
Yeah. Okay.
Yeah.
Then A to F. Also, all these normal dumb mistakes I would eventually find out during the checking. However, it is good that you guys mention it.
9 is a fun question in my opinion.
Yeah, I like 9. I've already seen it like before, so
Yeah,
it's fun.
like-
So we
like
have the
7
expected
times.
value of 3x squared minus 2x plus 4, and we know from the change
From
of
the formula.
formula, the change of insert, that is actually equal to 3x or 3 times the expected value of x squared minus 2 times the expected value of x plus 4. We know the expectation of, namely 3. So let me actually take a new line. So we know expectation of x is equal to 3, and more importantly, we know the variance. So we know var of x is equal to expectation of x squared minus expectation of x squared is equal.
Why is expectation done with square brackets? I do not understand it to this day.
Because it looks cool.
Yeah, it looks cool. So the variance is 3.
E's already has all those corners, so why shouldn't the bracket?
Touche.
And then we have the expectation of x squared, which is 9. So then we can say, if we add 9 to both sides, we get the expectation of x squared is equal to 12. Therefore, we can say that 3 times the expectation of x squared minus 2 times the expectation of x plus 4 is equal to 3 times 12 minus 2 times 3 plus 4 is equal to 36 minus 6, 30 plus 4 is 34. Therefore, 9 is D.
Yeah.
Yeah, boy!
Yeah, boy.
Choose a uniformly distributed random variable u on a unit interval from 0 to 1. Then, the probability density function of y is equal to ln of u plus 1 for y is bigger than 0 is...
Oh, I hate this function. Oh no, never mind.
So, let's see. We now have y is equal to ln u plus 1. Let's see. We know u is uniformly distributed.
Yeah.
would
So
just-
we know the f of u is u, like the capital F.
I would just like to extend my thanks to Siggo real quick for being a reliable piece of shit.
To what?
To Siggo.
Ziggo.
Oh, Ziggo!
Yeah, at least they're fucking you reliably.
No. You know what fucking happens?
Mm.
My internet dies, then comes back online. But my fucking computer, for some reason, that one isn't online, even though the router is back online.
Weird.
Good luck fixing it.
Okay, I have meditated on this question at least 5 hours. I know the answer, but if you want to go ahead.
Okay, so we have the probability density function of y, and again, probability density. That's just therefore I shouldn't say it like this. I should say
Small f.
small f of I guess like this.
Mhm.
No. It's not like this.
No.
So we know the random variable is like this.
Yeah.
We know the random variable u is uniformly distributed from 0 to 1. Then we know the f of u is let's see, from 0 to 1. So that's x over 1, which is x.
Yeah. F of u
Uh,
too.
But should we then wait? We're talking about the probability density function, so we should use this one, right?
Well, I mean, the probability density function of u is the probability density function of u is 1.
Yeah.
But I don't think we give a shit.
Fair.
I think well, okay. To be honest, if I hadn't seen the answer before, I would not know how to answer this
Yeah,
question.
no, I know what the answer is. I've seen how to do this before. I'm trying to figure out why.
I mean, hold on. Can I try something?
Yeah, go ahead.
Can we try the interval or the integral from negative infinity to a? Just fucking around.
For which one? For you or for y?
We're doing the integral for u.
But wait.
I'm thinking of no, never mind. That's just the then you just get the expected value.
Like, realistically, we know, right? Like, we could say y is equal to ln u plus 1. Then we know
y plus 1 fewer than y
e
plus
to the
1.
power e to the power of y is equal to, or it's actually u plus 1 equals to u plus 1. Then we know e to the power of y minus 1 is equal to u. So the answer is e to the power of y minus 1.
Well, no, I know a bit more about steps there, because f of u equals u.
Does it?
Yeah, because capital F, not small f.
Oh yes.
Yeah, we just calculated that. So f u of f of u is u. Say we know capital Y is ln u plus 1. Say we want small y is ln small u plus 1. So we know that since capital F of u is u, we can just exchange u for y because we exchange both the small u and the large u. It's like a substitution,
Yeah.
F of y is y. And let's see. Then the probability density function of y. And so that was the first, and there was another one which I may or may not have forgotten, but this was part of it. You know what? I don't fucking know. Just fuck this question.
Wait, which one are we looking at now?
10. We know the answer. It's C, but we don't know why.
Okay, uniformly distributed random variable u on the unit interval from 0 to 1. The probability density function of y is equal to ln of u plus 1 for...
No. The probability density function of y is equal to ln u plus 1 is for y bigger than 0.
Yeah. Okay.
So we want to figure out the probability density function of y, knowing that y is equal to ln of u plus 1, given that the probability density function of u is equal to
Okay. So we're transforming a uniform
uniformly distributed random variable. Yes.
to a probability density function of ln of u plus 1.
Yes.
So what we've got there is x from 0 uniformly distributed on the interval from 0 to 1. So u is that from 0 to 1.
Yes.
Mm-hmm. Then I think we should just take the integral from 0 to 1 as opposed to u. Or what? 'Cause-
But Tim
but-
recently gave advice in the PTS thing.
let me
write
just
it-
think. 'Cause
write it as f of u is p u smaller than u. And you need to rewrite it to
I
p
see.
y smaller than y.
Because
Okay, let's write it again then with that. So we know f of u. U is equal to p capital U smaller than u. And we want to rewrite this to something like
that
f
way or the other
in
way
terms
around?
of y.
Yeah.
the thing is, it goes from 0 to ln of 2. That is the
Mm,
Okay, so we have this, and we want to write that into some form of this. Also, why is the probability density function? Because I'm fucking up the names now. The probability density function, is that the capital or small one?
density
probability
is the small one.
density is small one. Okay, the density is for any one individual area, and then the cumulative is you take all these little f's, put them together, and you get a big F.
Yeah, but like, what's the big F called again then?
That's the
Distribution function.
cumulative.
Distribution function.
Distribution function, that's what I was looking for.
So we know p u smaller than u is u. Like, because f u is u. Yeah, and we know u is y. Oh yeah, okay. I'm gonna do some freestyle maths here.
Yeah.
We know u is e to the y minus 1,
Yes.
and we know small u is like, so capital U or capital Y
Yep.
is ln u plus 1. Small
Yes.
y is ln u plus 1. So practically replace all the u's with e to the y or e to the y minus 1, I think. Yeah. So
But
just
then
do
we
that
would
real
get.
quick.
but
No,
then-
just all the y's. Oh yeah, sorry. I thought I'm done. Continue.
Then we would get
B
F.
of yeah,
Of-
f y y, yeah.
f y of y is equal to p. Y is less than.
Well, no. E to the u minus 1 is less than
Well, we're
y
not
to the
replacing
u.
both, because then we have e to the u minus 1 is less than e to the u minus 1, which.
Yes, exactly. Continue.
Also, this is not true. We can't replace y by e to the u minus 1 because u is e to the y minus 1.
Is it though?
Yes. Y is equal to ln u plus 1. So here we have to fill
Yeah,
in
but
ln.
we have u, and we need to make y out of it. And u is e to the y minus 1.
Oh, so you mean like f of. E to the.
Y minus 1. And at this point, it's f of y, because you've replaced the u with the y, so we're not looking at this as a function of u anymore.
But like, if
Yeah.
I don't change the variables, this is what we have.
And then you also change the small u to the y.
But okay, let me see. So when
Where
we
you
when we change the capital U to the to capital Y, and then we transform that, that would leave us with this.
and now you do the same for the small u.
Okay, and
Yes,
then
okay.
but can we substitute small u? Well, yeah, it's just a change
Yeah.
of
The
variables.
the
but-
thing is, big U is just 1. And so small u. U
Mm.
are both because they are uniformly distributed random variable on the unit interval 1. 0, 1. Both formulas for
Yeah,
are
but now you're claiming that y equals to ln of 2, which is not true. Capital U is not just 1, it's a uniformly distributed
it's a
random
distributed-
variable.
yeah.
You can roll on.
Mm-hmm.
So let's see.
Yeah, no. But for the distribution for the continuous, the cumulative
Wait,
distribution function, that becomes x.
Jura,
That's just X.
it's not e to the. Yeah, we know at the top it says the community distribution function is u.
Yeah,
Which is
and u is equal to x.
well, yeah. We just use as a variable, but it's not
Yeah.
smaller than y. You need to. You can't just exchange that for y. It's also
Yeah,
e
no.
to the y minus 1.
But are we just...
We define y to be e to the u minus, or we define y to be ln u plus 1.
Mm-hmm.
But then this would be...
I don't think it changes there. Yeah, okay. You can fill in ln u plus 1, which translates to y.
Okay, so this would be...
Well, would it be?
No, wait, because...
No, now you just turned u into ln u plus 1.
Yeah, that doesn't make sense.
Then you need to, if you want to fill in something, it's e to the y minus 1. Or e to the, yeah, so u is e to the y minus 1.
So u is e to the y minus 1. Okay. So far we're still good.
Well, I don't think.
I mean, so far
No,
we've just replaced every u in capital U. Yeah.
Just ignore the left side for now, because we're just calculating with the p and the right side. The left side is something we derive later on. Just throw it away. Remove it.
Okay.
It doesn't mean anything to us right now. Because we're fucking around with variables. Right now it doesn't say anything. Now, inside the brackets, add 1 and take the ln.
So, okay, inside of these brackets, we add 1 and we take the ln on
Yes.
both sides.
Yes.
And then we take the ln.
ln.
Okay.
Yeah. So now we have the capital F of y equals to e to the y minus 1. We want the small f. And the small f is
Damn
the
it.
derivative of that. And the derivative of that is e to the y. And the answer is d.
Yeah, so this is equal to big F,
F,
of y. Y is equal to this. Then we have
Yeah,
small
well,
f of
small
y equals to d dy
of
Of-
capital F y.
capital F y y is equal to d dy of e to the power of y minus 1 is equal to e to the power of y. Huh. Damn it.
I'm gonna send a screenshot to this and add Tim. Is Tim in the call actually? Tim. Tim's not in the call.
Tim's not in the
I'm just
call.
gonna send a screenshot, because I think this is the most intuitive way I've seen it explained.
Let me actually wait before you do that. I'm gonna remove.
That
This
still
part?
makes no sense
Yeah.
to me.
And also this line doesn't make sense. So I'm gonna get rid of that as well. Okay.
Well, we know u equals to e to the y minus 1 because that's given, right? So we can just replace that. And we can, we know small y is ln small u plus 1. So we just, interchange that.
How do we know that u is equal to e?
It's given in the function. Look at that. Or in the question.
An uniformly distributed random variable u on an.
But y is ln u plus 1.
Mm-hmm.
Raise both sides to the power x and subtract 1, and we get u equals e to the y negative 1.
Okay,
And we
yes,
have
then,
u. We
then
just
I
replace that.
then I see what you're saying. Yes, that I can agree with.
Yes. So, yeah. Because Tim had this weird way of writing, and I didn't get it, but I think this finally made me understand.
I'm going to
So-
throw this into the chat and add Tim.
So the real thing that cracks this open is the fact that f u of u is small u. If not, all this factory couldn't be done.
Mm.
Yeah, okay, nice. We
Cool.
actually did it in a mathematically rigorous way.
Yeah, and now I actually understand that question. And hell, I even
Yes.
had it wrong. I thought the answer was E. Was C.
Yeah. People hands.
Hey. Okay, like everything before this took like 10 minutes, and now we spent half an hour on this one.
That's how it goes.
Yeah.
Yeah, but we have gained. We have a wrinkle has been added, Jure.
We have
Yeah.
gained
Knowledge.
understanding.
Brain wrinkles.
Ability score improvement.
Exactly. Throwing it all into comp because intelligence is a dumb stat.
Yeah, like, come on, you don't need intelligence.
Okay, 11.
Me only
11.
playing characters with high intelligence.
Consider the random variable x, which is modeled after the exponential function with variable 1. The expectation of y equals to e to the tx for t is less than 1 is equal to blah.
Like
Let's
I
figure it
just
out.
read the expectations of y, and my wrinkle just goes integral.
Yes. Okay, let's see.
I just imagine, I have to imagine like the wrinkle, like the two sides of it just like opening and like a mouth.
So the exponential thing with exponential y,
So
therefore
it's e to the negative x is your.
exp 1 is equal to
Read not.
it's not equal to right arrow f of x is
X.
equal to e to the power of negative 1
Curly brackets.
negative x.
Yeah.
And capital F of x is equal to 1 minus e to the power of minus x. Okay, this is not like. I mean, would this be incorrect when you think about it logically? If this is true, then these two things hold.
It's good enough. I don't give a shit.
Oh, I asked him like, does this make sense to you? And he said absolute sense. Tim
Oh,
Sensei
guys,
said yes.
By the way, just if
Nothing
anyone
is better than approval by Tim.
also if anyone didn't know, you don't have to print out the formula sheet. You can have it as a PDF.
I'm gonna
That's fine.
print it out, but thank
Print
I'm
it
gonna
out. Print it out. Like,
Yeah, but just so you know.
yeah, you can, but print it out anyways, because you know we know Graspel. It's gonna fuck everyone over.
Yes.
Or no Graspel, RP now.
The
I
fact
have
that
been fucked over once.
I've been
Yeah,
fucked
you
over
haven't.
twice, but like the fact that they have to say, imagine someone is just standing there, there with a fucking with a magnifying glass, ready to fuck you on any occasion, and try to plan for that. That just shows how they know how fucking horrible to use their program is,
Exactly.
and how little trust they put in their users, which is exactly the point. They do it right. The concept is flawed.
Yeah.
You
Fuck
can't
proctoring.
have a. I mean, sure, the entire concept is flawed because you put a post-it on your screen. What the fuck are they gonna do? But like, you know,
I get what you mean, honestly.
anyways, let's continue before it turns to a 2-hour vodka-fueled rant on the fucking education system.
So we are working on 11. Consider this random variable. The expectation of y equals to e to the power of minus tx for t is less than 1 is equal to.
Is it minus
Well, first
tx
of all,
or- Oh yeah, because you.
yeah, that's like literally
No.
or a positive tx. Sorry, my bad.
Yeah, I was about to say.
Then we have the expectation of x is equal to 1.
Well, why would it matter?
Yeah, I know. I'm just like thinking out loud real quick.
Wouldn't it just be the
So we
integral
have-
of?
Yeah. So the
Uh,
expectation of. Let me write this down a little bit more formally. So we have the expectation of y is equal to expectation of e to the power of, or sorry, lowercase e to the power of tx. Okay, so now we have this. And then we can say so that is equal to the integral. From
negative infinity to 1.
The nice
negative infinity to 1 of g of x times f of x. And we can fill those in already, honestly, so f of x is equal to
20, 30, 40, 50, infinity.
Yeah.
times x. It's g of x, e of x times x.
No.
No, it's for the expected value. It is the integral of the function times x.
no.
Because if you want the expected value of a function, then the x is your g of x.
Well, here we've got g of x times x is what we want basically.
No,
No,
because
g of x times
is
f of x.
G of x times f of x for the
Because-
expectation.
If you want the expectation of any function, you use g of x is x. But since our g of x is more complicated than x, we just make it instead of x e to the tx.
I suppose.
So expectation of
I see what you're saying. I suppose.
okay, good.
Jorre, hold up. Why is it -1 and not -x?
Good one. Thank you. Typo. So this will become equal to
E to the t minus 1 times x.
In here. So then we have minus t of x t times x squared.
Hold up. Jorre, je bent twee machten aan het vermenigvuldigen. Wat doe je dan?
Optellen!
Optellen!
Okay.
T -1 times x.
Okay. T 12 x minus x. Then this will be x times t minus 1.
T minus 1 is a constant, so you can
T
just
minus 1
like...
is a constant, so you can move that up front, indeed. Also, is it 2, 0? No, it's 2, 1. That's where my 1 was going. It do be zooming sometimes. Is equal to
e to the...
so
Yeah.
we differentiate or we integrate this, which is just equal
Oh.
to
You can also just get the e to the to the power t minus 1 just out front. And just integrate e to the x, like a Chad. Because right now, it would be, yeah, that.
Yeah.
But you could also move the e to the t minus 1 just out front and integrate e to the x, because e to the t minus 1 is a constant.
true, because these two are multiplied.
Yes. Wait, no, because
no,
they're
you wouldn't have the same answer.
No. It's because they're multiplied. Like I'm just.
Yeah, because you can only move them outside of each other when they are.
Yes.
Yeah.
When they're multiplied. And then right now you would have to move a power function out, which is just dumb.
Yeah, you're not gonna move power function out. Either way,
I really wish the graph.
so we have infinity minus 1 to the power of. No, wait, I'm fucking it up. It's the other way around. Either way, does this make sense?
Negative
Isn't
infinity.
it 1 over?
No,
t
it's
minus
negative,
one?
negative infinity. Thank
1
you.
over e to the infinity. So that's 0.
And the guy who said it's 1 over is right when we're working with integrals, differentiating a constant e to the power of constant times x is actually equal to 1 over that constant time.
True.
Yep. Okay, and then this infinity thing makes a lot more sense.
No, it doesn't. We're integrating over x. We're filling in.
But yeah,
x.
okay, but then still, it's negative infinity, so this will go to 0.
But
so let's see, it's top minus bottom, so it is filling in 1 minus filling in minus infinity. We know filling in minus infinity here gives 0. So this is the same as just filling in 1 for x. So therefore the answer is this. Once it, yeah.
Yeah. Problem is that's none of the things that are shown. So somewhere we did an oopsie.
Let's see, is there a way? No. Okay, yeah, we want the expectation. Wait, we were calculating expectation.
No, you weren't.
Yes, we were. That's literally what we were doing. However, we were calculating the expectation of e to the power of t times x. That's capital X. Can we do that just like that?
No, you have to fill in the function in there and then times x. That is at least how I understand it. As in, you have to fill in and take the e of x. Like you have to put
The expectation
mu
of
e minus
g of x of some function g of x is equal to the integral from minus infinity to infinity of g of x times f of x dx. This is a fact. Let's see, where is it complaining about? Oh, this one. And I also have to put this one.
the things you're not multiplying it. You're a g of x takes big X. Y equals to the e to the power of tx, so it's not multiplied to the power of the function.
But here you have to like if you have an expectation of x big X squared, then your function here would be small x squared. So here if we have e to the power of t big X, then this is t to the power of small x.
I suppose. I'm just. Well, either way, we're not getting the right answer.
Yeah.
Yeah.
So either way, one of us is wrong, and
No.
or both of us are wrong, even.
Yeah, it's probably one of the two indeed. One of us are wrong, or both of us. Jurre is wrong,
Yes.
but where is the question?
Yes.
And are you right?
Yes. That's the other question.
Yeah, wait, let me grab a piece of paper so that I can think.
We have the exponential distribution with 1. So small f of x is equal to this. Yes. 1 e to the power minus x. Yes. The expectation of y is equal to this thing is what we filled in here. Yes. That's the integral from minus infinity to 1. Wait, I think we're integrating over the wrong thing.
Yeah, yes, you are.
For t less than 1.
Oh, yeah, dt then.
Does that make sense? Because
no,
no.
you're not trying to integrate
No.
dt. You're just.
Oh, so this is just a limitation on our input values.
Yes,
Yeah.
your x should still be from 0 to infinity.
From minus infinity to infinity.
Yeah, that's the only way we can like remove the x.
Yeah.
Or the e.
You know, it makes sense. This t is.
It's,
I was looking at it wrong. This t is actually just some fucking function value thing that we do not know or care about for now.
it's
This shouldn't
0
impact
to
anything about
infinity.
our original thing. So this should
Yeah.
still be from minus
It is
infinity to
0 to infinity because you're using an exponential where x is more than or equal to 0.
Does it say that though?
Yes. For x more than or equal to 0.
But
Yeah, but like
Does it
the
also-
reason
I thought it
if
only
you
applied
don't-
to the big F. Does
no,
it
no,
also apply to
if
the small?
you don't, it's an improper integral. Right?
It has
No.
to be equal to 0 because otherwise you get infinity minus 0 or vice versa. Just
I see. So I thought this part only applied to the big X, but it also does to the small
no,
X.
it has to apply to both.
So then this becomes the integral from 0 to positive infinity.
Both have to have the same domain, but the range can change.
So let's see.
The domain for small f and big X is always the same. The range for small x can be anything, but the range for big X is 0 to 1.
Big X or big F?
Big F, I mean.
I like
Not
your
0 to 1,
integral.
0 to infinity.
0 to infinity, yes. No, but the range.
Oh, the
not
range as in the
domain.
output, not the input. Okay, yeah, fair.
Yes, I'm talking about range versus domain.
Can't the range of f of x be more than 1?
Range of small
small
f
f.
can be more than 1. Range of
Range of large x has to
Can-
be between 0 and 1.
has to be exactly 0
exactly
to 1.
0 and 1. Yeah.
So let's see.
I-
Yes, and then this x here becomes 0, so the answer is just.
Well, what happens if you
Wait,
fill in infinity?
Yeah, what about to say? What if we fill in infinity? Well, it's top minus bottom. So then we would get infinity times this, or e to the power of infinity times this, minus this thing.
Then clearly you've done something wrong, haven't you?
Yes.
Yes, that's what we're trying to figure out.
Mm-hmm.
Come on, we're at 22 in the call. Someone just point to us what's wrong. Come on, people, pay attention.
Okay, let's just find the expected value formula, just so we have. Because
Yeah.
Okay, that's this one.
it is x f of x dx from negative infinity to infinity.
No.
Because we're
Expected
working,
value of g of x is g of x times f of x dx.
because what you're talking about is a subclass of this where g of x is just x.
Mhm.
Yes.
But the thing is, we're not multiplying it by e to the power of x. That's not what we're doing.
This is the function we are taking the expectation of, e to the power of dx. This is the function f of x.
But they're not multiplied by each other. Is the thing. That's not what we're trying to do.
Here
We're-
we are.
you're working with.
No, we're shifting. We're shifting. What's the first function called? The expectation of 1. No, the exponential distribution 1. We're shifting it by e to the tx. And warping it. We're not multiplying it.
See if I can find the formula.
Yeah, I will actually grab the formula sheet for you.
Guys, there's nothing wrong. Okay, so I figured it out.
Okay.
T is smaller than 1, which means that t minus 1 is negative, right? So when that integral goes to infinity, that will be 0. Right?
It's smaller than 1, therefore this is. Oh
yeah,
my
yeah.
god, you're a genius.
Nice.
Fucking hell.
Yeah.
Damn. Oh, that is so. Oh, wow. Okay. Thank you.
And this is why we need a few more voices.
Yes, this is why 2
Exactly.
people arguing is a lot worse than 5 people arguing. Just to make sure, I will actually show you the lecture, which we were talking about though. So
Because
it is
it's good
about
for everyone to just like have a look at it.
expectation, variance, and change of variance. Then we will go to the lecture slide, and we will scroll down. This is about expectations. So we will see here, indeed, when you have the expectation of x, it's just x f of x. When you have the expectation of g of x, it's g of x f of x dx.
I suppose that.
The lecture slide is right there.
It's right here.
I suppose. Hey.
I suppose.
Okay.
We're here to learn.
Yes.
Yeah.
We're not shaming anything. We're just glad to figure it out.
Yeah.
So let's see. This
Took
is
us half an hour. Next question. Jesus Christ.
Next question. This is so. Let's see. Our integral here is correct. Let's see. This
1 over
becomes
t minus 1.
this becomes 1 over t minus 1 times e to the power of x times t minus 1. I really hope we don't get a question like this on the thing, but at least we can do it now. From oh wait, what the fuck? Oh yeah, I pressed the wrong key on my keyboard. From 0 to infinity.
It's yeah.
Okay. Again, I said when we fill in infinity, this will be e to the power of infinity times t minus 1. However, t is less than 1. So less than 1 minus 1 is equal to
Negative.
a negative
zero.
number. So this will tend to 0. So then we get it's top minus bottom. So we fill in 0 for x here. And then, yeah, so we have minus 1 over t minus 1. So let's see. So this is equal to...
Which becomes 1 over 1 minus t. That can be rewritten as 1
yeah.
over
So we
1
can
minus
put this to the bottom, which becomes minus t minus 1, which becomes 1 minus t. So the answer is
F.
F.
In chat.
So we have 11 F. Okay, took it long enough. This is good. We're learning, guys. Nature is healing.
We are the true math is the true virus.
Yes. Come on. Y is equal to e to the power of t of the discrete random variable x. Word dreamed up by the utterly deranged.
This is what they have been asking years of government assistance and student money for. We have been taken for fools.
Hello, I would like x approximates exponential 1 apples, please.
Can I have a Poisson distribution from with an input of minus 17 cars, please? They have taken us for absolute fools.
Can I have
This
the
is
square
real-
of your
yeah.
variance, please?
Yeah, this is real stochastic done by real statisticians.
Okay, let's continue. So we need to know the following.
We need to make that meme. Like
Yes.
anyone make that meme now.
We need to know about the following statements. If they're independent, correlated, and if this thing is true. I'm going to start with the top one because that one looks the most fun. Probability of xy is even is equal to
let's see. So x, y is even. So then we want. Well, that's realistically only 2 times 1, 2 times 2.
It's everything
Three
except for
times
the
Yeah,
correlation.
everything except for these 4.
Yeah.
Yeah. So
So then we have
all minus 1 minus 3
It's-
12.
1
It's
over
X,
6
X or
plus
Y or both are even.
1 minus
1
3 12
over
equals
6
3/4.
3/4. Yes.
plus 1 over 12 times 2 plus 1 over 4. Recompile.
You're doing it from that that way around.
So that is, let's see, that is 1 over 3, this is 1 over 6.
Yeah, because in this case it can't be mistaken for an improper fraction, I think it's called.
Yeah.
Because a 2 and a 12 could be mistaken for 13 over 12.
Yeah.
Mhm.
Either
No,
way,
not
this is,
This can't.
25
This-
over 12.
yeah, this is
Oh
like
yeah.
this, so this is 1 over 6.
6.
That means we will have 3 over 6, which is 1 over 2 plus 1 over 4. And that's 3 over 4. So, yes, A is true. So
Math
then it
isn't
is.
broken yet.
So then it's either B, E, or F.
Independent is
B.
also wrong because
They are not independent because if one is 3, the other one cannot be 3.
Yeah, this is a pretty.
That one is intuitive.
Yeah, like we can say P of X is equal to 3, comma Y is equal to 3 is equal to 0, but P X equal to 3 times P Y is equal to 3 is equal to, well, the chance of this thing happening is 1 over 6, chance of this thing happening is 1 over 6 is equal to 1 over 36. And because they're not equal, they are not, they are dependent. So B is false. So it is either B or E.
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 formula for dependence.
Okay. Then we have the covariance, the correlation formula. And we know something is correlated if the covariance is not 0.
And the covariance is
Cov
expectations of x, y
Yeah,
minus
cov x,
expectation of x
comma
expectation
y
of
is
y.
equal to EX, EY minus EXY.
Oh, are you sure about that? Because the way I remember it, it's ex, y.
Yeah, it's
minus
different.
E,
Yep, the other way
y.
around. Because
Yeah,
if you
minus-
fill in y is equal to x, you just get the variance of x.
Yeah.
Okay, so we have this thing, and then we can actually just literally calculate this. So we have the
Literally calculated.
yeah.
The absolute madman.
So we have the expectation of xy, which is equal to 1 times 1 over 12 plus 2 times 1 over 6 plus 2 times 1 over 6, which is 4 over 6, plus 3 times 1 over 12 plus 3 times 1 over 12, so that is plus 6 over 12, plus 4 over 4 plus 1, plus 6 over 12 plus 6 over 12, which is plus 1 again. Let me see if I actually did my math right there. That is 1 over 12 plus 2 times
Can we
2
just
times
say
over
that-
6 plus this one plus
Can we
this one.
just
That's
say-
6 over.
Can we just say they are dependent, so automatically they are correlated?
No.
Correlation and independence are two different things.
Yeah, but like one implies the other. I'm just not sure
no,
which.
no.
Corre- Yeah, man, correlation is just a way of measuring the linear
Correlation
dependence.
correlation implies dependence. Dependence does not imply correlation because you could have, for example, a middle value where, for example, if x was 2, then y would have to be 1 or 3, but it would not make it tend one way. That would still be dependent, but it would not be correlated. But here you can actually just see that if it's 3, then it tends to be lower. So we already know that it is correlated.
Yes, cool. We're still gonna calculate it.
Yeah. But I'm
Because
just
we are
saying that
thorough.
independence does not prove correlation, but correlation does
Yeah.
prove dependency.
Yeah, because the correlation proving independency or dependency also makes sense when you think of it of a methodical way. Like if you look at a graph and it x goes up as y goes up, that's correlated. But like if you think about that must be dependent.
Correct.
Yeah, like there's this slide here.
For there to be a correlation, they must be dependent, but for there to be a they must not be
Yeah. So
correlated
this is
to be dependent.
this is a
Look at the slide.
correlation. This is a correlation, yeah. So when they have like some kind of effect on each other, it's correlation. However, the effect has to be like when one is positive, one is positive, when one is negative, the other is negative, or the other way around. However, these two are obviously fucking dependent because the one is x squared. But they're not correlated because there's no like straight line you can pull from one side to the other. So correlation implies dependence, but dependence does not imply correlation.
Yeah.
Cool. So then we're gonna calculate this. So this is let's see, this is 8 over 12. I'm actually gonna write it like that as well, which will give us 8 over 12 plus 6 over 12 is 14 over 12, 15 over 12. So that's 2 plus 15 over 12. Which is actually 3 plus 3 over 12.
How long is the midterm, by the way? 3 hours? No, 1.5
Hour
right?
and a half.
Interessant.
Like all the other math ones.
Yeah, they can't make it any longer.
Yeah. Is this one also 1.5?
Yeah,
No,
I'm
it's
not
2.
sure.
This one's 2.
Oh, okay. Great.
So we're halfway there and we're like...
What halfway there?
Anyways.
Question about
I
have a quick question about A.
Well, okay, we if you guys want, we can still calculate the rest of this question, but we can...
I think it's a good.
No, actually,
I think it's a
let's
good
do that.
thing
So we
to
have
do.
e of x is equal to... So the expected value of x is equal to 1 times the expected value of x, so that's like this one plus this one plus this one. Or the expected value of x is equal to 1, so...
Yep.
A third.
A third.
That's a third, yep. That's 1 over 3. 3 plus 2 times the expected value of when x is 2, which is 1 over 6 plus 1 over 4, that's like...
A half.
I really like having people calculate shit for me. Plus 3 times...
A sixth.
There we go. 1 over 6. Okay,
That-
to be fair, I
that's
could have
the result
calculated
of
the
my
last one
teacher-
myself as
yeah,
well.
That's the result of my teacher forcing me to do calculations in my head.
So that is 1
Even if
over...
we were allowed calculators, yay.
what was the other answer again for the expectation of x? So this is 1. This is a half, so 1.5 plus 1/3 is like 5/6. So it's 1
Yeah.
5/6.
1, 5. No. Yes. Yes. Yes.
No, yeah.
Yes, yes.
And like realistically, right? Because this thing is symmetrical around the x-axis, or around like this diagonal line. That means that the expectation of y is the same thing, right?
Yeah.
So then I'm actually going to write it as 11 over 6, and therefore e x e y is equal to 121 over 36. Again, this follows from the fact that this thing is symmetric, so the expectation of y is equal to the expectation of x, and they're both equal to 11 over 6, so that's 121 over 36. Which
Imagine if you just get the midterm and they go, take x, take the probabilities of x and y as a symmetric matrix.
Oh no. However, we can see that this, let's see, that,
that's 3/1/4 minus this is correlated.
not 0.
It's not 0.
So therefore, they are correlated. So A and C are both correct. So the answer is 12 E. Next
Question
one.
about part A.
Hmm?
I have a quick question about part A of the question. It says x y is even, right?
Yeah.
But I thought x times y, there's also the probability that you can have when x is 3 and y is 2.
Yes.
Why
So
wouldn't
it
you
is.
include that?
It is when this case,
Oh wait,
this case,
yeah,
this case,
we forgot it.
in this
Yeah,
case.
we included that.
Oh, you did include. Oh.
Yeah.
Maybe my math was off.
A third plus a
So-
fourth plus a sixth.
Okay, thank you.
Yeah.
No problemo. I feel like this subject used to be a lot scarier before we did this.
Yes.
Mhm.
Let's see. So the joint commutative distribution function of the pair xy is given like blah. The joint distribution density function is
Joint
for
probability
blah blah blah. This. Okay, that's not too bad. So they only ask for this case, and we only have to worry about this case. And they are asking for the small f. So
would say-
realistically, what they're asking
yeah,
for is the integral from
Derive
0
both. Wait,
to.
the integral? We're going from larger
We're
to
always for
smaller,
derivative. Yeah, so we have
Yeah.
d.
Actually, it's delta.
Yella, do you want me to smack you across the face with a baguette?
And double actually, it's d squared.
Yeah, d squared.
Jure.
Do it!
Just do it.
And then we can pick the order.
Just
Well, actually,
do it. I'll
Yes,
be
you can.
okay. Just.
Yeah.
okay.
So
I'll-
are you saying this made the subject much less scary? Made me think of a title of the Latexicist.
so then we have
to get on it, make a custom role for Gura. I know he
6
already has
x
one, but-
cubed y.
The
correct?
last of the
No.
latex.
No.
Let's see. We subtract 1, and then we put it up front. Yes.
Honestly, at
so then
this
it's
point,
just 2x squared y.
at
no.
this point,
I am literally too dumb to like do derivatives at this point.
Why?
The derivative
What
of
do
x
you mean?
squared. The derivative of x squared is 2x. Okay, it's 6x squared plus y. Or x squared y.
Yes, it's a.
Yes. I was just having a mental moment.
Jure, I think we know what your fetish is now. It has to be latex.
Ha 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 ha.
Ha ha ha. Okay. Assume x
Well,
is a positive
technically-
random variable. Which of the following statements is/are true? The expectation of x squared is bigger than or equal to expectation of x. Sorry, cubed is equal to expectation of x quantity cubed. And the expectation of 1 over x squared is less than or equal to the expectation of 1 over. Huh. So what they're realistically saying here is expectation of x cubed is greater than or equal to expectation of x cubed. I messed up my bracket.
Oh,
Did I do that
I'm
sometime?
getting for the second one. I'm getting hard, fucking. What do you? No, you're the sentence doesn't end there.
I was about to say full stop or.
No, God, Trebuchet. I'm getting trebuchet inequality here
Trebuchet inequality.
because yeah, I'm getting trebuchet inequalities here. Or flashbacks.
Okay, we
Yeah,
know that.
Both of them. I'm getting trebuchet inequality flashbacks for both of them.
Okay, we know that the first one has to be true because variance can't be negative.
Let's see, -2. So this is what they're realistically saying. They just wrote it in a really dumb way.
Yes.
Yeah, we know the first one must be true because variance can't be negative because variance is standard deviation.
Well,
squared.
variance is squared, not to the power 3. But I guess.
Well,
well,
then we can just say that we have a random distributed variable. Like let's say we have a random distributed variable called z, and we say x is equal to z to the power 1.5. So then x is equal then x cubed is equal to z squared, and I probably fucked something up there, but you get what I mean.
We can't do trebuchet, by the way, because we don't know if it's convex or concave.
Yeah.
So yeah, and then I would just go off intuition and knowing that e to the x squared minus e to the x squared must be greater than 0.
Yeah.
Therefore, e to the e x squared has to be or is greater.
Let me write it out. So
Yeah,
we
thank
know.
you.
Yeah. So we know e to the x squared
I was wrong.
minus e to the x squared is greater than 0. Therefore, we can say that e to the x
greater or equal.
squared is greater than. Actually, it should be greater than or equal to.
Yeah.
greater
Because
than
if
or
you have
equal
a single
to
point, the variance is 0, I think.
e to the x squared, or e to the x squared. My intonation here is really important.
Yeah.
Um,
And I think from this you can just like manipulate. No, you can't manipulate functions because you can't like e to the x squared is not e to the fourth or e of x to the fourth. But I do think we can take some wisdom from this. So A is like if this was on a test and I didn't have much time, I would say A is true because of this.
yeah, but B and A are both like the same thing. They just have a negative exponent or a positive exponent. Well, okay, no, and actually the sign is flipped. That's my bad. Yeah.
Guys, you can use Jensen's inequality for this, I believe.
No, because we don't know if it's concave or convex.
Well, you can draw it out, I think.
No, because it's
There's no formula given.
positive continuous random variable, so that doesn't tell us anything about whether it's concave or
It
convex.
is a positive continuous random variable.
Yeah, so so to use Jensen's like, but I said Chebyshev, I meant Jensen's. Thank you for that. But yeah, we can't because we don't know if it's concave or convex. But
you can find it out by taking the second derivative.
Well, how? Okay,
And
we
taking
know it's a positive continuous random variable. We take the derivative of what?
Tell whether it's
of x to the power 3.
It's
Take the
x to the
second
power
derivative
3
there.
is g. We need the derivative of f, and we
Oh,
don't
we
have.
don't have.
Yeah, all we know is that x is a positive continuous random variable. It might be the sign. It might be.
Actually, it would be sign plus 1 because otherwise it wouldn't be positive.
Yes, but like we know it's something. We don't know what it is, so we can't just take. We can't just say it's concave. Hell, because we know it could be 1 plus sign. We know it's not. It doesn't have to be either concave or convex. What would the sign? What would 1 plus the sign of x be? It would be neither concave nor convex, right?
Yeah. Let me throw you a curveball here.
Yes.
And there is something wrong with my statement because if this were true, the variance could not exist. However, I'm going to out it anyways. Say that we take the gx to be x squared.
Yes.
Then, following from Jensen's inequality, this would mean that every x is always positive or concave. Say we take g to the x to be x squared. Oh no, because one implies the other, but it doesn't imply the other way around.
Yes.
But
Okay.
why are we taking x squared instead of?
No, because I was saying a hypothetical. But
yeah, no, but what he was saying is not relevant to the question. He was just like in general.
Yeah.
Speaking.
Okay. So we
At
know
this point, I would
what.
say both can continue because I have no clue how to attack this question.
Does anyone here have any idea how to tackle this?
Which question are we on? 13?
14.
14.
14. Okay. X is a continuous a positive continuous random variable.
Yes. That's all we know about X.
Okay. So we have a continuous random variable. That's good to know, and it's positive. Good to know.
Yes, doesn't tell us much.
E of x cubed is more than or equal to ex cubed. So, given that it's always positive, this is true.
How do you know? Without a rigorous claim.
Sure, dude, just trust me.
No, okay, wait. Because if
Jesus is always the answer.
Let's see here. Let's first of all think of the case where x is more than 1. For any case where x is more than 1, this is true. But for any case where x is less than 1, this is false. Or for a case where the expected value can be less than 1, you can have.
But we can't put a relation between the expected value of e of x and the expected value of e of x cubed. Like you can't express one and the other.
No. But you can use logic to think about this. So think about, first of all, one where all the values are higher than 1. Then it's pretty obvious that it's gonna be x, that is true. But look at one where the values.
No, like that's not obvious at all. If you say that the expected value of x is bigger than 1, you cannot draw any conclusion about the expected value of x cubed.
No. Because what you can what you can think of is if first of all, just think of this simple case where all values are at least 1 and more. Every single value gets cubed. That moves. That means that, for example, if you just have 100, you have you have 100, and you have 99 ones. What is the expected value of that?
199 ones.
199 ones. What is the expected value of that?
I believe something like 2 or something. I don't know.
About 2.
Ish. Yeah.
So you cube that 100, and you
Well,
cube all the ones. What do you get then? An expected value that is up in the like a lot higher than 8.
It's higher at least, yeah.
It's definitely higher than 8.
Sure.
Because the high value getting like that pulls the expected value more than the low values, and thus for more than 1 at the very least you get it that that is true. Because the higher values pull farther, basically.
Wait, hold on. I think I found something out.
But for
Yes.
less than 1,
Mm-hmm.
for less than 1, say you have well, you have 0 and 1.
Guys, this is just Jensen's inequality.
No, yeah, but like the thing is, we don't know anything about it. However, we can make assumptions,
Yep.
and that's what I found out. You can just say, "Say it's positive," then one of the two is right, or say it's convex, then one of the two is right. Say it's
they're
concave,
both
the other two is right.
convex.
So no, they you can't say that they're convex. You don't know.
Yeah,
if they're
because we
convex.
know X is positive.
But
we know X is positive, so its expectation is positive, right? I mean, it's convex.
Okay, let me try you
They're
guys.
both convex.
This here is a graph. This is a positive function.
This is not convex or concave on like.
No, but
like
the power of third, like the function, the power of third is convex on positive numbers.
Well, it's, x to the third, like. Yeah, gx is
yeah.
convex. Okay, you're talking about gx. I think.
Gx is x to the power of third, which is the function that we apply on here. Yeah, so it's basically the function in Jensen's inequality, right?
Jensen's inequality, I believe fx needs to be convex, but I'll have a look. I could be very
Let's have a look.
No, it's gx.
Which one was that? Is it an
convex lex? Remember?
Yes, but like we don't know if we're talking if convex, if gx or fx has to be convex.
Let's see. Where's that equality? Wait, was that in the pre-lecture video of this one?
Yeah, it was pre.
No, this is Chebyshev's inequality.
No, yeah, I need Jensen's.
I think it's lecture 5 or 6, something like that.
It's lecture 5.
I believe it does say gx twice differentiated greater or equals 0. Is this g of x?
So let's see. Yeah, watch this video about Jensen inequality and convex functions.
Because if it's g of x, then this is an easy question.
Transferring joint density.
Yeah, they don't talk about it.
Oh, they only talk about it in the pre-lecture. Okay.
No, yeah, they're right. It's the outer function, not the distribution function. Yeah.
Okay. Yeah.
G. Okay. No. Then you're right.
Okay. Cool.
Then
I thought the
is
convex had to be the random variable, not the outer function. But then this makes a lot more sense. Thank you.
Then the outer function is. Well, it's con. Let's see. Con. Is it concave? No. Wait. Dubbele afgeleide groter dan 0. Yeah, double.
So we have the g of e of x less than or equal to e of g of x. We know the g of x is equal to the cube, so this is cubed. So this is x cubed. So this will be the case if
Is
g is convex.
Is the sign the right way around?
Here it says less than or equal to, so.
Yeah, okay, for convex.
Oh.
I thought they gave some kind. Okay. Yeah. So convex is like this. Concave is like this.
And a to the x or a to the third. Or
x
to the
cubed.
third.
Yes. Is.
Dubbele afgeleide groter dan 0. Which means it is. We didn't have this in primary school, to be fair.
Yeah. Me neither. If it's convex, then it's bigger.
Yeah.
Yeah. Okay. And the like second derivative of this is like 6x. Since x is positive, then
Yeah, then it's going to be greater than 0, so it's convex.
yeah, and but convex is leg, so then this thing holds. Okay. Okay, so this thing holds for a convex function. Now what is it what we want to prove? That is that this is. Yeah. Okay. So one is correct. Cool. Let's do it for the second one as well.
But that's a concave function.
Is the second one a concave function?
Yeah.
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 So that one should also be true.
And they're both correct.
Okay, then they're both correct. So then we say 14 is.
Not gonna lie, I've just given up on Jensen's, and I will not answer any question.
The less than an equals is the other way around.
Yes, but because it's concave, that's the reason. If it's convex, it's
Why
greater
the
than. If
second
it's
one
concave, it's
It
smaller
is
than.
also convex.
Is it though? Second derivative is. Oh yeah, you multiply. So it's the
6 over
second
x to the
derivative.
power 4.
So the first derivative is negative. Second derivative turns positive again. So it's only the first. You're right.
Yeah. Okay, that makes sense. So it's only one.
By the way, in the exam, don't try to calculate the second derivative. Just try to graph it out and see if it.
For this
No, I will calculate the second derivative because like
faster at that.
I do not thoroughly understand the concept of concave and convex well enough to be able to look at the graph and say that's concave or convex, and I'm not interested in learning it well enough. Okay, consider the two normally distributed random variables. Compute the 25th percentile. Can we calculate percentiles? Isn't that like statistics?
25%. Yeah, but they don't give a shit. It's just p smaller or equal than 25.
That's fair.
Woo.
Even 0.25.
Yeah.
Okay.
Z is.
Yeah, I was about to say. So we can't compute this without the table. So we know that we have this x, which is simulates a n 2,9. We know y simulates a n 3,16. And therefore, z is equal to x minus 2 over. And let's see, on the right side there, that's sigma squared. We want sigma, so that's 3. We have z, or let's say z like zx, and z y is equal to fraction y minus.
No, we can just first get s and then get z from s.
Yeah, I'm not sure what you're gonna do with this, Jure.
Yeah, okay, we can. Yeah, okay, that makes sense. What you guys are doing makes sense too.
Doesn't help you that much.
So we have s is equal to x plus y. Therefore, mu of s is equal to mu of x plus mu of y. Which is equal to like 2 plus 3 is equal to 5. Okay. And then we can have sigma of s is equal to sigma
squared. Don't forget.
I think it's the square root of sigma.
Square root of both squared.
Sigma x squared plus
5
sigma y squared. And again, these are already sigma squared, right? So this is just the square root of 9 plus 16 is equal to 5. By the way, did we derive this somewhere earlier? Like, I remember this from middle school, but I'm not sure if we can just use it like this.
Yeah, I believe
It seems logical.
We did derive it from somewhere.
Yeah, like the sigma of s squared, so the variance is equal to the variance of one plus the variance of the other as well then.
Yeah, I mean, they're added like on top of each other.
Yeah,
so it
I'm
makes
pretty
sense
sure.
that it's more spread out.
Let me see if there's anything in the formula sheet. Oh, it won't be on the formula sheet actually, but like...
Yeah, it makes sense that it's more spread out if it's two normally distributed added together, especially if they have different means, because like...
No, okay, what I was looking for actually... What I was looking for is variance of s is equal to the variance of x plus y is equal to the variance of x plus variance of y. That's what I was looking for. We did get this.
You can even take it a bit further, saying variance of 1x plus 1i is 1 squared variance of x plus 1 squared.
Like that's what implied here.
Yeah.
Yeah.
So we know this can be done, and again we're taking sigma, which is like the variance of sigma squared, so we're taking the square root. Therefore, S simulates a normal distribution of 5,25. And we want to know P of S is smaller than 0. No? Let's see, what's what we want again? We want the 25th.
25. Right.
We want the 25th percentile. But do we then calculate this is less than 0.25, or do we calculate
is less than
well,
no.
Okay, so we were calculating the
you want P equals 25 is 0.25.
Yeah.
So P of x is smaller than 25. Or 0.25, and that you can look up in the table.
So S isn't a standard normal.
Yeah, we can't do that yet. So we're looking for this then.
Yeah. So we
Yeah. Okay.
and
then we can calculate this. So we have P of S is less than X. Then we have P of Z is less than X minus 5 over 5.
Over 5. Yeah.
It's less than 0.25.
Is that less than 0.25?
Oh yeah, we also
Do we?
No, I don't
think we do.
No, I think this is right.
Yeah, I think so as well.
Okay.
Okay. So
let's
what you can
see.
do now is go in the table and
Go
look
in the
for
table. Look for. Wait. So these are which tail probabilities? These are
left tail.
Yeah,
Right.
but this is left tail. This is, and this is right tail. So we need to do actually 1 minus this. So we need to have P. Actually, I put a sign here. So P of Z is greater than 1 minus.
Actually, it's greater or equal. No one gives a shit. It's the same.
Yeah, it's continuous, so it doesn't matter. X minus 5 over 5.
Capital X technically, but
Yeah, that's correct. My bad.
you also have to do 1 minus the right side.
Yes.
Yeah, to do both sides.
No.
No, like this thing is still the same.
Oh yeah.
Yeah, because this is like the answer. The answer will stay the same. So then we have the chance of.
Is this even true?
Hmm?
Wouldn't it be P Z greater or equal than thing equals or Z smaller equal?
What we're doing here is we have this bell curve. That's not a bad. That's a very bad bell curve. And we're saying this chance is equal to this chance, and the chance itself is the same.
Z smaller or equal than say the right side is 2. Z smaller or equal than 2.
That's smaller than equal to. No, that doesn't make sense because we're using smaller than equal to 2 would make it this area.
Yes.
Yeah,
and then we would turn that to this area.
Greater or equal than 1 minus, but it isn't 1.
Hmm.
That wouldn't be 1.
What do you mean it wouldn't be 1? We have this bell curve. We have Z being smaller than some value. It doesn't matter if it's to the left or to the right of the middle. And if we want to get right now we have this value. If we subtract 1 minus
I think what you mean.
It's not 1 minus. It's minus.
We want to find something that is to find something that is less than 0.25. We need to find something that is greater than 0.75.
Yeah. So This is correct what you wrote now. However, I believe it is the formula we've been taught is p z greater or equal than x minus 5 over 5 is 0.75. That's the formula you're trying to use, I believe.
Fair, but like logistically speaking, this will make sense too, right?
Yeah, but
yeah, both work.
Because you just literally you restated this exact same thing twice.
Yeah, because it's like yeah, exactly. And that's what I want. So now we have a right-tail probability.
Yeah.
And now we can just look up where.
You didn't get anywhere with the rewriting, so.
Well,
yeah, we did.
We did.
So now we can check for the 0.25 here.
0.7.
So the 0.25 is somewhere between 0.668.
Sure,
7 and 0. It's somewhere between these two.
It doesn't matter. Take 0.68.
Okay.
Because it's closer
so
to
then we
69.
have P of Z. Oh.
But then we know 0.68
is bigger than
is
0.6.
Wait, no, you need to find 0.7. You need to find 0.75.
Man's a robot.
Table itself, and then find the probability number.
No, yeah, but we know now that 0.68
Oh, you can't
is
know.
equal to negative 8 or
yeah.
x minus 5 over 5. And then we can find that x there. Also, is it large x? I think it's small x in there.
Yeah, it's small x because this is a number.
Yeah.
Yeah.
And
Cool.
the last one also needs to be small, and then you can start calculating.
Yeah, and then we can multiply both sides by 5, so then we get 0.65. Or
Times
68
5.
times c dot 5. I'm gonna also subtract, like multiply both sides by -1. Then we get it equal to x minus 5. Then we can say minus 0.6.
Wait, why are you multiplying? Oh yeah, because there's a negative there.
Minus 0.68 c dot 5 plus 5 is equal to x. So that's the number that we wanted to calculate. So it's 5 minus, well, this number will be like something like...
I would say it's C then.
Yeah, it's going to be close to 1.5.
Yeah. So I say it's
because
15.
this is going to be like minus 3.5, and this is going to be minus 3.5 plus 5 is about this. So it's going to be C. Okay. 3 more questions, and we only have 15 minutes. Woo. But we had some interesting arguments throughout the thing, so an actual test would take less long.
During a test, we would just not have the arguments. We would just be wrong.
Yeah, we would just be very wrong multiple times. But that's alright. We're learning.
But shit, for this it actually matters what you get because if you get a 10 here, the other one you can just get a 2.
Yeah.
Oh dang it. Okay. Let x and y be any random variable, but possibly with different distributions. Which of the following statements is always correct? The covariance is between 1 and -1.
1 is wrong because that's the entire reason we have the fucking small row, you know? Because this can be like a million.
Yeah,
small row
but then we have to divide that by the variance of x and the variance of times the variance of y, and that will be turned into the
so
the
1 is
factor.
Wrong. So it's either D or F.
So let's see, 1 is wrong, so this one, and this one is wrong, so I either D or F. So then we can have a look at 2 or 4, and if one of the two is correct, then yes. See, y is x plus 1.
Oh, 4 is correct. So it's D.
The variance of x plus y is greater than...
I believe it is.
The
variance... Oh, no, because they need to be independent. Are they independent? No, they're not. So 4 is not correct, so it's F.
Let me have a look about that. So we have the variance of x plus y is greater than or equal to the variance of x plus the variance of y, minus, if they're not, just in the general case, it's the variance of x plus y is equal to the variance of x plus the variance of y minus...
Plus the covariance of
minus
XY.
2 times covariance, right?
Oh yeah. Yeah, that's very true.
Yeah, so minus 2 times covariance, and if they're positively correlated, then the covariance is positive. So that will be variance of x plus variance of y minus 2 times a positive number.
So it's wrong.
Yeah.
So it's F.
So it's F.
That was fast.
Okay, assume the job submission or vertically unit tender can be modeled by a Poisson process, and that the average job submission is 4 per minute. What is the probability that at least 5 minutes will elapse between two job submissions? You see, this is the thing where we use instead of like px bigger than small x, we use p of t bigger than small t, and I have no clue how any of that shit works because I don't think it was explained to us.
I think my biggest problem with this question would be which distribution is this, but luckily if
It
you
says
look
Poisson.
at the...
It says Poisson, modeled by a Poisson process.
Hoggers. Okay, great.
Yeah, and again, the Poisson process is like this one. However, did they ever go about those?
Wait, I want to have a look at the question. I think there's
Yeah.
a simpler way than having to look up a formula. So, so 4 per minute.
So then the
it's
input is
Poisson
4,
4.
right? The mu.
Poisson 4.
Yep.
And we're trying to find probability that is
5.
that is 2 per 5 minutes, 2 per 5 minutes at least. So that would be
No, what you want is 5 minutes of zero. You want 5 minutes of zero. Poisson is very simple. To multiply the time, you simply multiply the 4. So 4 becomes 4 times 5 equals 20 with an expected value of 20. What is the chance of 0?
Yeah.
Okay, did they ever go over this?
Yeah. I don't think they did, but it's not too difficult, I'd say.
So it should. Is it an independent one? Well, yes, because Poisson does not have an F in it. So then they should have gone over it in this lecture. So let's see. Did they get base rule, set theory? I don't think they did.
Well,
maybe
either way, we'll figure it out now.
Maybe it's not for us anymore.
Well,
but it's still useful to know.
Now you know at the very least.
Yes.
So yeah.
So we get Poisson distribution with of 20. So we have fraction 20 to the power of 0 over 0 factorial times e to the power of minus 20. So this is the left side is just 1. So the answer is e to the power of minus 20.
Okay, because you want 0 for the first minute, and 0 for the second minute, and 0 for the third minute, and 0 for the fourth minute. So it's a 4% distribution, and you add the expectations, you add the variances. So so mu is 4 mu, meaning that you multiply them.
Yeah.
Which probably makes a lot of sense in my head, and not much in anyone else's, but sure.
I can follow.
Okay, so let's see which one also was that.
That's F.
So that's F. So we
And
have
F in the chat.
17F.
This is something
Seriously,
I would
why
not
there's
have
so many people joining?
Whenever you say it, it makes sense.
The exponential distribution is used to represent the radioactive decay. Let x be the time in years that a carbon-14 atom takes to decay to a nitrogen-14. That means that the time of decay is blah 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 years.
No, the mean time of, not that
the
means
mean
the
time,
time.
yes. Yeah. The mean time of decay. Yes, I thought they say that means that. Okay, yeah.
Yes.
The half-life particle T is such that is yeah, okay. So we have a Poisson distribution. So let me actually write that out. So we have x is mid Poisson of 8 to...
Isn't it POIS?
Well,
I don't know. I'm
the
very
mean
bad at
is
stuff.
A2. So the mean is A2. So what is the mean compared to the input value of a Poisson?
The input value
It
is the mean.
the mean. Then that's correct.
Yes.
Yeah.
And I use mid here. There should be sim. So
X, well, we know that.
I will cry. So then we know. Let's see. So we have Px is equal to k is equal to fraction of 8,267.
Wait, hold on.
To the power of
Px is
k
equal to k.
over
This
k
is a
factorial.
continuous thing, isn't it? Oh no, Poisson. Never mind. I was looking at exponential, like an idiot.
Like an idiot. Okay. So we have this
like
one.
a liar.
Equal to k is a half, right? That like we want to get to. Is a
We
half.
don't want it equal to k at all. We want it to be greater than.
Okay.
Okay. So now we know that this. Shouldn't the input be a full number? No, it should not. Yeah. Wait, it should be.
Yeah. It is.
What?
It's greater than a full number is a half.
Wait. If it is a discrete function, then bigger than a half is only 1, 2, 3,
No,
4.
it's not bigger than a half. It's greater than t is a half.
Greater than t is a half. Yes. Okay. Cool.
Yeah. So I have to find.
You can probably rewrite this to be left tail probability, but
Yes. So
I would write it as a left-tail probability and then start plugging in
yeah,
0, 1,
sure.
2.
Because like when we know that like the thing x is being is bigger than t is equal to a half, then x is less than or equal to t is also 1/2.
Yeah.
So then we have px less than or equal to t is equal to 1/2.
Yeah.
And because it's
now,
discrete, we can just sum up stuff until it's a half.
Yeah. The thing is, what? How? Can you draw me a poisson, or is it poisson?
Yeah, it's Poisson.
Do we know it's poisson? Did it say that?
No, this one was
it says that
exponential.
it's Poisson.
Are we doing the carbon 14 now? That one's
Yeah.
exponential.
Okay, yeah, that makes a lot more
Yeah.
sense.
Okay. I was like, huh?
I was like, what? Why? Okay, yeah. No, I just read it wrong. That's my bad.
Then one over.
That makes the question a
the-
lot easier as well.
So it's an exponential. So it's exp.
So it's actually
1
exp.
over. 1 over. It's exp 1 over 8 to
Yeah.
6, 9. Because ex is 1 over lambda and it's exp lambda. And so ex is 1 over lambda.
Yeah.
And
oh yeah, so the
exp
expectation, the expected value is this thing.
Yeah.
So it's actually
Yeah.
Okay, therefore the chance.
The one thing I remember from like physics is that it's going to be a big number. Like if I remember correctly, it was like
I mean,
2,000
it's
years at
either
least.
2,000, 4,000, 8,000, you know, so. The big brain player is just remembering it from physics.
Yeah. I did a poster on it once.
So we know this is the f of x. And also times x, of course. My bad.
It's e to
and
the
it's minus.
or it's e to the negative alpha, isn't it?
Yeah, I was about to say, so it's mine. Also, you're looking at this one. It's actually this one.
Again.
It's still negative.
Yeah, it's
so
still negative. You're right. So it's actually this. However, I'm going to rewrite it in terms of t because we're working with t here. But we know that actually f of t is actually equal to p of x is less than or equal to t.
Yeah, so we can just
So
do
we
t
can just
if,
set these two equal to each other. So we can just say 1 minus e to the power of minus
t
fraction
over
of
blah.
d over 8267 is equal to.
Oh, I think we're gonna do some funky maths in here.
Over 2.
You forgot.
Yeah, it won't be too funky.
No, you didn't.
No,
So,
I think there might be a small bit.
at
Oh,
all.
I use.
Yeah.
Okay, let me do this math.
A slight bit of funky.
Let me do this math. So we will start off by adding or subtracting 1 from both sides. This will turn into
doing both sides
negative. Then I will also multiply both sides by -1 to make it easier, which will leave
There's
us
a
with
slight
this.
bit of funk going on. We'll see.
No, not too much. So we will be left with this. Then we do. Then we take the ln on both sides. So we have the ln of this thing is equal to just this thing. Then I will take the minus sign to the other side, and then I will multiply both sides by this number.
That becomes negative ln of 2. May I remind you?
Mm-hmm. And that's the funk because then we know ln of 2 is
No,
about.
not really. Like okay, so this is 2 to the power -1. There was a minus in front of it. This comes ln of 2. So we have ln of 2 times this number. We are allowed to use calculator, so I will just grab this and say 2. Give me the natural log.
Nice.
This is nice. This is the thing I'm annoyed by. So if I take the exponentiation of this, wait, is equal. Does it not? Okay, whatever.
Do exponent 0.69. It'll be about 2.
Oh my god. Fuck off. 0.69 exp.
I don't think that's what the exp
I
does.
don't think that's what the exp does.
It's e to the something. Anyway, whatever.
No, but like I'm not sure if this is American or not. So I'm not sure if this is.
ln is e. Log is 10. I know that for sure because otherwise they would use log for both. There is no country in which if log is not equal to ln is e.
Okay, cool. So then,
ln is always e because it's a natural log.
No, because in America ln is actually I think in
ln is e, but log can be either.
Yeah, log can be E as well.
Log, unless otherwise stated, generally assumed to be 2 or 10, depending on what you're working with.
Or
LN
E
is
if you're in
always E,
America.
E in America.
which is just
E.
stupid.
Yes.
Yes, but it is
Okay.
a fact, so I was curious which one they use. But
So
given
zero
that they're in the
guy
Netherlands,
it
it's
says the guy who
probably...
uses Imperial.
So it's
Yes, Alan, this is a
5,730,
call out for you.
What?
It says
which
the
is
guy.
A.
Hey. Okay,
That
done.
stupid
50
says the
seconds
guy who used
remaining. Holy
Imperial.
shit, speed done. Stop
I
your
don't
timer,
fucking
Jelle.
use
Stop the
Imperial.
timer.
Yes, you do.
Actually,
you
Jelle,
said that.
we started 3 minutes late. We were overtime.
I don't use Imperial, Conrad. Where do you get this from?
Because you don't have problems converting them.
Yeah, I
Wait,
have no
okay.
problem converting
Now you
whatsoever.
go check the answers.
Wait, give me a
'Cause we
sec.
could- Sure.
Somebody is sending me that it's actually variance of x plus variance of y plus 2 times covariance, and I thought it was minus 2 times covariance.
Let's have a look.
So let's see, they discuss covariance in this this
Two
one.
functions. Covariance is yada yada. Plus.
Yada yada.
No.
Somebody just, while they're looking, somebody give me an idea for something to build in KSP.
It was above it.
It is plus. It is plus 2 times covariance.
Hey, so I wasn't retarded. So then we got the answer wrong.
Yeah.
Then it
Let's
is.
check our answer anyway. So
Yeah.
these are the answers. So recompile. So I'm gonna keep track of how many we had wrong.
Yeah.
1 is correct.
Reminder that I said it makes me less scared, not scared.
2 is correct.
3 is correct.
Wait, where's
4
3? Oh, 3
3
here.
is
That's correct. 4 is correct.
correct.
5 is correct. 6 is correct.
6 is
7 is
correct,
correct.
7 is
8 is
correct,
correct. No, 8 is wrong.
8 is wrong.
Okay, we're gonna revisit that one in a
Yeah,
bit.
okay,
9 is
I'll
correct.
remember 8.
10 is correct. 11 is correct. 12 is correct. Wait, where's 13? 13 is correct. 14 is correct. 15 is correct.
Correct.
16 is wrong.
Wrong.
8,
But we
16.
just figured out why. 17 is correct,
17 is
and
correct,
18 is
and
correct.
18
We
is
we
correct.
know why
15
16 is wrong.
16. So we only we fuck up multiples of 8.
Yes.
Yes.
Wait, this is like a very easy one. Why did we fuck this up? Hold up.
How did we fuck this up? So, exactly one opens your front door. After each try, you drop the keys on the ground, so you no longer know which key you just tried. What is the expected number of keys you have to try before opening the door? You can probably apply some sort of birthday paradox or some shit, but
It's
like,
geometric 1/6.
yeah. So it's geometric of 1/6. Then the expected value of 1 over 1/6 is equal to 1, or equals to 6.
Correct.
Did we fuck up? We wrote down F, right?
No, you wrote down C. You wrote down
No,
3.
it's
No.
for 8.
We're working with 8, so we wrote down F.
Oh, F. What was the
What was the
correct
answer?
E.
It was E, so it's 5.
They say E. They say
I
5.
think they don't count the one
What
the
is
key
the-
you open the lock
Yeah,
door
you
with.
don't, they don't count the one that's the key.
Which is simply wording, which is stupid.
Yeah, okay. They
caught
caught us on a technicality. They caught us on a technicality.
Lees dan de vraag.
That we would just complain about.
They should have said, what's the number of keys you have to use
Because
before finding the one that opens the door? So they should have said something like that.
Because by their own writing, before
Yeah.
opening the door, you
Yeah.
insert the key and turn it before it opens the door. Thus,
Yeah.
6 is correct by their own writing. They
Yeah.
just wrote a bad question. So fuck them. I would easily take that up with them and just get the points for that. No problem.
Yeah.
For 16, let's have a look because the 16 we did wrong on 2 tries, but because it was So we know now why 4 is wrong, but then that means that 2 is also correct.
Yeah, but I didn't look at 2.
Fair.
Yeah.
Want to have a look at 2, or shall we have a lunch break and go for the second exam?
Yeah, that sounds like a lot more fun. So we kind of went over time, but we also had very heated discussions about like a multitude of things, like 5 out of which were not even relevant to the exam.
And me just being stupid.
Us being stupid. Sayos.
Comrade. I mean, don't we have a guy who literally calls Comrade here or something?
Yeah, we have Conrad. Of course we have Conrad.
Yeah.
Conrad is our main man.
Yes.
Yeah, I'm always
Yeah,
here. lurking in the
Conrad,
shadows.
but everybody knows that Conrad is just a radical con man.
Ooh.
Yes.
Either way, let's take a break, 15 minutes.
Yes.
And then we will do the midterm of 2019.
Honestly, the thing I'm worst at is just knowing what everything means. I can use the formulas, but if you ask me, hey, if you point a gun towards my head and say, hey, give me a
concave function on it.
Hey, I just
no,
met
give,
you.
give me
But
a
this is
fucking
crazy.
Poisson distribution. I would say, what the fuck? Put down the gun. I'm gonna call the police.
Hey,
And I would
I
also
just
not
met
know
you.
it.
And this is crazy. But here's my number. Now, what's the Poisson distribution of this look like?
Yes. Yeah, we're going to have a break. So.
I remember in fucking middle school, we were told, we have a Poisson distribution, but we're not going to tell you about it.
Yes, that's like
Fuck jou, Kouwenberg. Or
no, it was Kouwenberg. It was Kouwenberg.
It was Kouwenberg, yeah.
Yeah, Kouwenberg. Real G.
Poisson distributions are chill.
Yeah, true. She a real OG. Anyways, we're gonna have probably tosties.
Yes.
Oh, fuck. Come over to my house with one.
Actually, we also have fudge. Like, we have 2 big bowls of fudge.
Fuck off. Come on over. Wherever the hell you live. You now live at mine.
Sorry, bro. COVID. Can't do it. Guess we're gonna have to eat the fudge alone.
Is this an invitation? Wink, wink.
No, stop.
Yeah, boy.
No, I don't think my girlfriend would approve of that unless she gets some fudge too. Okay, I am going to have a break. See you guys in a bit.
Everybody gets some fudging.
Okay, to be fair, in a communist utopia, everyone will get fudge. Bye bye.
Yeah.
You get fudge. Everybody gets fudge. Konrad, shall we break off to a debrief of Eurovision?
Sure.
All right, it is 13:45. Let's get started with the with the midterm of 2019 instead of 2017 this time. Okay, again we have 16 questions.
Well, last time we had 18.
Hmm?
Well, last time we had 18.
Oh, we did? Cool. Huh, cool. I'm going to remove. I'll actually throw it in the channel.
That's going to be a long one.
It's gonna be message.txt.
Yeah. Let's see. General VC message.txt. Again, if people want to see part of this, just paste it in the chat and it will fill itself out. Okay, then we can delete this. Delete. Um, how can you not compile this? Ah. Okay. Use of a non-graphical, blah blah blah. Exam consists of 16, blah blah blah. Color the boxes black or blue, blah blah blah. Course name, blah blah blah. I don't care. Assume you play the following dice game. You win one round if you throw a fair die and get a 6, or you throw a fair die and do not get a 6, but then throw a second time with the same die and get a 6. You will play n squared rounds. Denote x is the number of times you win. What kind of distribution does this have, what are its parameters, and compute the probability that you win at least 2 times if n is equal to 3. Okay. So let's see. So the chance of winning is, let's see, then we can calculate the expected value. Namely, it's 1 over 6 plus 5 over 6. So the rest, and then also 1 over 6. Oh, yeah. And I'll actually say this, P die 1 is 6 plus P die 1 not equal to 6 and die 2 equals 6. Okay, so we have the chance that we win, or I'll say P win, whatever, is equal to the chance that we throw a 6 the first time, plus the chance that we don't throw a 6 the first time and then throw a 6 the second time. That's equal to this. This will become 5 over 36. And this is 6 over 36, so the total answer is 11 over 36. And yeah, so this is just one trial. You play a game, you have an 11 out of 36 chance. Motherfucker. You play a game, you have an 11 out of 36 chance of winning. By the way, can you guys hear me?
Yes.
Cool.
Yes.
All right.
I agree so.
Okay.
I agree so far, and I think it's A.
No.
Actually, wait. Overall, you play n squared rounds.
Yeah, it's D.
Yeah.
So you play n squared rounds, so you end up with a binomial distribution of 11 over 36 n squared.
And winning 2 times with 9 rounds is something like 0.84. It's
Yeah.
gonna be high anyways.
Yeah. Actually, let's do the calculation. So we have I'm not sure if there's a nice way to choose.
Yeah, I think for now it's just 9 times 8, isn't it? I think for now it's just 9 times 8.
Well, yeah, okay, true.
Like, I'm not sure. I'm very bad with this, but
Yeah, it is true because it's like 9 times 9 factorial divided by let's actually
7
get this.
factorial.
So it's,
Oh no, I was wrong.
let's actually write this out then. So we have the bin. So x is
It's 9
binomially
times 4.
x is binomially distributed with the chance of 11 over 36, and
And the amount of tries
there's
is
n
n
squared
squared.
rounds. Okay, then the chance of, so we know p of x is equal to, so x is the number of wins, the chance of the number of wins being 2, and we'll take n to be 3, so n squared will be 9. So the chance that we win 2 games is equal to fraction of 9 factorial divided by 2 factorial times 9 minus 2 is equal to 7 factorial times 11 over 36 to the power of k, which is 2, and then times 1 minus 11 over 36, which is 25 over 36, to the power of 9 minus 2, so that's to the power of 7. And again, this formula makes sense. So you have to win twice, lose 7 times, and then you can permutate that in n choose k ways. Yeah, cool. So then we get 9 factorial divided by 7 factorial. That's 9 times 8. 9 times 8. And then we divide that by 2 factorial. So that's 9 times 8 divided by 2 is equal to 9 times 4 is equal to
36.
36. Thank you. And then we c dot a large number.
So
I'm actually
36
going to just
times
enter this in the
11
calculator.
or times 121 times what the fuck?
Times a big number.
Oh, they're like. Oh, it's 36, not 24.
So yeah, 36 times
Open
11
bracket.
times 11 divided by opening bracket 36,
Well, 36 times
36 times 25 to the power of 7 divided by 36 to the power of 7. That does not make very much sense. I think this first factor might be wrong.
Hmm.
Wait, okay, so your chance that you win one game is 11 over 36. Oh, I messed up the notation, by the way. They messed up the notation then.
What?
Yeah, they messed up the notation.
It's
They
at
do
least-
chance, comma, amount of trials, but it is amount of trials, comma, chance.
Yeah, whatever.
Bunks.
they
Either way,
say at least 2.
Yeah, it's 2 or higher. Yeah, we can't do the
At
math
least
for it,
2.
just D.
Oh, yeah,
Yeah.
okay. So that is 1 minus... Yeah,
The
okay.
chance for 1.
So it's at
Or
least 2,
average
so
plus
this is
1 minus chance for 0.
greater than or equal to is equal to 1 minus p of x is less than 2 is equal to 1 minus p x is equal to 0 minus p x is equal to 1. Filling that in gives some kind of formula that will lead you to the number that we just got. I'm not going to calculate this again because the calculation takes time, but you know, like even without this, I would just know that, okay, this is n squared. We do n squared trials, so the answer would be d. Then we have these two variables with the following joint probability function. We need to calculate the covariance, also 1d. We need to calculate covariance. Popping up with word. I don't care about these. I don't want to review those files later. So we have a joint probability function with this stuff, and I need to compute the covariance of this. So I'm going to make a table that consists out of, let's see, so we have x is 1, 2, 3, and we have y equals 0 to 6, so that is 3 by 7. Actually, I'll do 4 by 8.
It can be 3 by 3. That's why it only takes the value 0, 1, and 7. Or 0, 1, and 6.
Yeah, that's true. However, I'm just going
It'd
to do
be
it
more
like
workable, but up to you.
I'll do it like this. But it is true. You can also make a table that's smaller. So we can have x equals 1, 2, 3. Y is equal to 0, 1, 2, 3, 4, 5, 6. So we know x is equal to 1, y is equal to 0 is equal to, let's say this number is I, and it's equal to the chance of x is equal to 1, y is equal to 1. So these two numbers are the same. That we are not given actual probability. And then we know that the numbers x is equal to 2, y is equal to 6, so that this one is equal to 1 over 3, this one is 1 over 3, and the rest is equal to 0 because it's not mentioned. However, we also know that the total probability of everything here happening has to be 1. So we know that this is 1/3, this is 1/3, then these two together should be 1/3, so this is 1/6, and this is 1/6. And again, that makes sense if you look at it. So the chance of, like, the cumulative probability x equals 1 is equal to 1/3, 2 is 1/3, 3 is 1/3, and the chance of y equals 0 is 1/6, 1/6, and this is 2 over 3. So this is the eventual table. Yep. Then we need to calculate the covariance. The covariance of x comma y. Oh, actually, I should put this over to my left side and work here. So we know. Oh. So we know the covariance of x and y is equal to expected value of x. Actually, expected value of xy minus expected value of x, expected value of y, because the quantity squared goes on the end. Okay, so we can calculate expected value of xy, namely 0 times this, 1 times 1/6. So I will write that down. That's equal to 0 c dot 1 over 6 plus 1 c dot 1 over 6 plus, let's see, 12 c dot 1 over 3 plus 18 c dot 1 over 3. Recompile. So this is the number we want to figure out. So this is, wait, what the hell is it? Oh, I should probably add the fraction symbol. That helps. So we have 1 over 6 plus 4 plus 6. Is that correct? Yeah, so we have 10 plus 1 over 6. So that is equal to 61 over 6. Okay. And I'll actually write this as EXY is equal to. And then we calculate expected value of x, expected value of y. So we know expected value of x is equal to. So we have 1 times 1 over 3. And just to be lazy here, we know that all of them have the chance 1 over 3 for x. So I'm actually going to write 1 plus 2 plus 3 times 1 over 3 is equal to 6 times 1 over 3 is equal to 2. Do you guys understand what I'm doing here?
Yep.
Yeah.
Okay, cool. And then we have the expected value of y is equal to
Well, I'm gonna leave out the 0 times 1 over 6 because that's just 0. So we'll have 1 times 1 over 6 plus
6 times 2 over 3.
Yeah, 6 times 2 over 3. And this will be actually be equal to, so we have 6 times 2 over 3, that's like 20 over 3 plus 1 over 6. 20 over 3 plus, let's see, this will actually become 40 over 6 plus 1 over 6. That's just 41 over 6. Okay. So then we know covariance of x comma y is equal to the expected value of xy, which is 61 over 6, minus the expected value of x times the expected value of y, which is
82 over 6. Yeah.
over 6. So this has a
So-
negative covariance. Namely, well, actually, we can just also work this out. This is, what is that? Minus 19 over 6, I think.
Yep.
Cool. Okay,
No, minus 21.
Yeah, okay, my bad.
Which could be simplified to 7 over 2.
Yes, however, we made a mistake somewhere because it's not wrong. It's not correct.
How did you get a 41 over 6? I got something else for that.
Oh yeah, no, then I oh this yes. I made a mistake in this calculation. That's my bad. So this is 4 over 3 or 4 over 6 times 6 is equal to 38 over 6. This is, or
no, 24 over 6.
24 over 6. Sorry.
So 25 over 6.
25 over 6 instead of 41 over 6. My bad. So then this becomes 50 over 6. This becomes 11 over 6. So the answer is 2E.
E.
E.
We're contractually obligated to do that every time the answer is E.
Yes.
No.
Okay. Let Z be a standard normal variable. Compute the expected value of blah 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 and the variance of blah blah blah. Okay, that's not too hard. So let's see, calculating the expected value of this thing. Well, that's just the integral from minus infinity to infinity of e to the power of 4z times, and then we have the
standard normal variable, so
standard normal variable. And like for an actual normal variable, this is pretty hard, but for a standard normal variable, it's doable. So the average is 0, and the thing here is 1. So this is just frac 1 over square root of 2 pi times e to the power of, I'm actually going to write exponent, minus 1 over 2 times, well, it's basically x minus 0 over 1. So that's just x squared.
X. A half x squared.
Yes.
Yeah, you have minus a half x squared, yeah.
Dx?
Yeah. Also, why did you do x and not e?
Yeah, I thought this was going to be a lot bigger, so I'm actually going to do e. Like when it's really, really big, I do x, because otherwise it gets like really tiny up here. But this is workable. Okay, so what we're going to do then is I'm going to take this 1 over square root of 1 over square root of 2 pi. And I will take this out front. And then we can add these two exponents together. Oh, and also this should be z because we're doing dz. These nuts.
Hey.
Okay, so then we add these two together. So then this becomes our exponent. Okay.
Right now, now I have to think. What if there's like a lumberjack convention called SawCon, when they get prank calls all the time?
Fork on these nuts.
Is this SawCon? Yes. Fork on these nuts.
Okay. Now I've seen this one before actually.
What's SawCon?
Um.
We have fun here.
Okay.
No.
I mean, yeah, that's the point.
P of x, where x is we have fun, is 0.
Let's see.
Ooh.
This is an integral that kind of sucks. I'm going to take e to the power of 1/2, or e to the power of minus 1/2 out of this fraction, out of this top part. So actually, I'm going to make more steps than I usually would with this, because this is going to be a complicated integral. But we do have to do it. So it's e to the power of minus 1/2, and this becomes minus 2. Is that correct? No, this becomes minus 8, and this becomes 1. Wait, that's a multiplication. Oh no, that doesn't help because I can't split it up. It kind of does help, but less than I hoped it would. And now I'm going to do what's called a pro gamer move. First I'm going to rearrange
You can take the
this.
Z out.
And what I'm going to do is I'm going to complete the square. So we have z minus 4 squared.
How dare you?
And then this would be plus 16, but we have to compensate for that, so we have to do minus 16.
Minus 16.
Oh, yeah, there should be things here. Okay. Yes, okay. So this is already a lot more workable than whatever we had over here. I'm going to distribute this minus 1/2 out to the minus 16 as well. So this will be plus 8. Is that correct? So yeah, minus 1/2 times minus 16 is equal to plus 8. And then because this is an addition, I can just take that e to the power of 8 out to the front. Now this is something interesting. So now what?
It will be oh, that's actually, yeah. This is interesting.
So it's already better than before, but it's still not ideal.
You could replace z minus 4 with like u, and then...
Yeah. Let's do a u substitution. Say u is equal to z minus 4, du is equal to dz.
These nuts.
You
shouldn't forget to change the bounds from infinity to infinity plus 4.
You're hilarious. So this will be u du.
You do you.
Can we actually do e to the power of 1/2 u squared? Actually, okay. What I'm gonna do first is I'm gonna make another substitution.
We could substitute u, yeah.
So first of all, this instead of making it 1/2 u squared, I'm gonna make it 1/4 u squared. So then I can say t equals to...
That doesn't work out.
Does it not?
A quarter squared is 16.
So this should be 1 over
root 2.
Square root of 2.
Yeah.
Okay. So then we have 1 over square root of 2 u. dt is equal to du because it's just again a constant. So that will bring this to fraction, or actually I will copy this whole thing again. So you guys remember calculus, right?
I don't know. This is really
Yeah.
The square it still won't do anything because
if you fill in infinite, this will just be 0 to 0. So it's just e to the power 8 over square root of 2 pi, isn't it? Yes.
But you can't just fill in 0.
Well, you can fit a negative infinity, and then
No, you
it will
can't
be
fill it in because we
negative-
haven't integrated yet.
Well, okay, then I still think it's going to be 0, but sure, knock yourself out.
What distribution is it?
Normal.
Then it will not be from 0 to. It will be negative infinity to infinity.
Yeah. Like we know.
Yeah. So what was the 0? Who was
No,
trying to fill in
Yellow
0
was like
where?
saying if you fill in 0 here, it will be 0, and if you fill in infinity here, it will be 0, and if you fill minus infinity, it will also be 0. However, the graph will still look something like.
Well,
the graph will look something like this, right?
Something is going fucky wacky here, because there is no way we're ever getting anything to do with pi out of this thing, out of the integral, right?
Yeah, there's nothing here with pi, so it's probably 0. At this point, if I would look at it for about 10 minutes more, and I would be like, okay, there's nothing with pi here. I'm just gonna take the one with 0.
Well, if the initial expected value is 0.
But it can't be that one because the variance is negative there.
Then something went wrong.
Wait, yeah.
Wait, no, the variance of 5y z minus 40, the variance of this thing is 1.
The variance of anything can't be negative. Like, variance is never negative because it's the square of omega.
You can have an imaginary omega, but not in this case.
Well, only, yeah.
Let's actually calculate 2 first, and then we can have a look at that. So we have variance of 5 times z minus 40 is equal
Isn't
to
that just 5
variance,
variance
25 times the variance of z
Yeah.
is equal to 25. Or, yes. Again,
Yeah,
omega here is 5, but they're asking for the variance of.
So it's A or D?
So it's either e to the power 4 or e to the power minus 2. I'm curious where the fuck that.
No, it's either e to the power 4 or e to the power 8.
Oh, yes. So these two.
And I think e to the power of 8
the other one, the other one is e to the power 8. So I would say put our money on e to the power 8 and
yeah.
call it
No, but
a
I'm curious why that doesn't work though. So we have the normal distribution, which is this one. This omega or the. Yeah, this is 1 or minus 1, but I'm not sure if the minus case would be applicable here.
Yeah, no. I'm gonna be real with you, Chief. Not a clue. What's the calculation again? Can you show me the It's e to the 4z is the calculation, or the gx.
E to the 4z minus. Oh, the gx is e to the 4z, yeah.
I'm gonna be real. I would say we've been spending way too long on this. Take one, move on. I myself would go for A, where it's e to the 8.
I'm so confused why the 2 pi would just go away.
Magic.
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 Somebody look in the PTS chat. Tim has probably said something about this. Until then, I will bet my money on D.
Yeah, D. That's the one I meant. Okay, we're 1/5 of that like thing, and 1/3 of the time.
One fourth.
Could be worse. Could be worse.
Okay, so we have PA, PB is 0.4, PC is 0.5.
Actually, 1/5 of the time. We're cruising. Whoa.
Okay. So we know for a fact that A and B are independent because P of A times P of B is equal to P of B, P of A and B.
Yeah. So P.
It's
either
one,
A, C, or D.
Yeah.
And P of A and P of C are also independent.
Let's see, P of A and P of C. Yep, that's correct. So the only thing that could be dependent is So it's
And the thing
either
is, we
A
know
or
that as
C.
well because P of B is 0.4, and P of B, if we know C is 0.4, meaning that C has no effect on B, meaning that B and C are independent, so they're all independent, so it's A.
Woo!
Okay.
Speed run.
Yeah, sounds good. I would calculate it out
You know-
myself, but you know, actually,
Well,
your
like,
your
the
thing.
thing is, Jura, your way of writing independence is P, B, and C equals PB times PC, yes?
Yes.
Well, yeah. So divide both sides there by PC. So then you get PB equals PB and C divided by PC, right?
Yeah.
Wait, give me a sec. Somebody sent me a message saying just put the square root of 2 pi inside, and you have a probability density function of the standard normal distribution, which is 1 from minus infinity to infinity. But like then we would have like this thing is 1 from minus infinity to infinity, but we also have this thing. Wait, what we could perhaps do is integration by parts, where we integrate this thing, which will be 1, and we differentiate this thing, which will be 4 e to the power of...
by parts. You can't integrate by parts from one place to another place.
Not?
No. Integration by parts is just get the antiderivative, not actually integrating. I would say let's move on.
Okay. Either way, like we have this part of this probability density function, and we're trying to...
Yeah, 1
Wait.
over square root 2 can be taken outside of the brackets. That's the
Wait,
whole
no. This guy's got a point.
Hmm?
If we put this 1 over square root of 2 inside of the brackets, we'll have 1 over square root of 2 e to the power of minus t squared, which is a probability density function for some z. In this case, let's see, is there a way to make it so that... no, then we would multiply... So here we have a half over a half u squared. Yeah, so here we had e to the power of minus a half u squared. Yeah, okay, I'm gonna do this one first, sorry, because I know how to do this one now. So we did this substitution here for t, that one is useless, I'm gonna get rid of it. I'm going to take this 1 over square root of 2 out of the brackets again. Bring it up here, this will just be 1 over 2. And this will be u squared. Thank you for your input, Yix. You just saved this question. So here we've got the and then I'm also going to take this 1 over square root of 2 pi into the bracket. Yes. So we have frac 1 over... Okay, so if you look at it now, we have e to the power of 8 times the integral from negative infinity to infinity of 1 over 2 pi times e to the power of minus a half u squared. But this thing is simply equal to this thing, just with a different formula. So this is just a standard distribution, a normally standard distribution, standard normal distribution. So we know this is equal to 1.
Is it standard?
Yeah, like if we take the normal distribution thing, we fill in 1 for mu, or 0 for mu, 1 for sigma, we get this thing.
Yeah.
Yeah, so this is just e to the power of 8 times 1.
Okay.
Oh, that makes so much sense. That's so smart. So it's just like, what we realistically did is we completed the square, we got this plus 8 out of the brackets, and we turned it into another distribution, which is 1. I see. Cool. That's a cool question. I like that one. Continuing on.
So we had 4 done, let's see, 5. On King's Day, 60% of the Dutch population wear something orange. Overthrow the monarchy. From the people in orange, 80% of the has painted the Dutch flag on their cheek. What is the probability that you meet someone on King's Day in orange and with the Dutch flag on their cheek? That's a dumb question because it doesn't say how many people you meet. So we have P of, or let's say A is wears orange. B is Dutch flag. And we are given P of A is equal to 1 or 6 over 10. We are given that P of B is equal to 8 over 10.
No, no.
Oh, from the people in orange,
It's
80%.
from
Yes.
the people in orange.
So that's B given A.
80%. Yeah, B given A.
Okay. What is probability that you can meet someone on King's Day who is both? Well, this is just a really easy question because we have P given A and we have A.
That times that.
So, what do you think?
It's just that times that.
Yeah, exactly. It's just multiply. So it's
C.
Yeah, it's C. So we have 5C.
I really was this year's midterm also gonna be multiple choice?
No,
Because
unfortunately
no,
not.
sadly not, because Graspel is a bitch.
Wait, Graspel should be able to do multiple choice.
Yeah, it does. They're just like, no, not for you.
True. Somebody send me a PM saying 4 is wrong, so we can have a look at that one again.
Yeah, why is 4A? I'm pretty sure they're all dependent.
Well, at the very least, B and C are independent.
No, at the very least, A and B are independent. At the very least, A and C are independent as well.
B and C are also independent.
But are they also independent?
Yeah, because you can see probability given C is
Oh,
equal
yeah.
to the probability.
Yeah, okay, so
B.
let's have a look at 4 then, like the answers, because I am going
I
to be
thought-
very careful with scrolling here.
No, just let's reason through it again.
So we had
B?
4B.
4A.
No, like, sorry, we had 4A, they had 4B. So they say they're all dependent.
What?
Huh.
B given A and C. Because probability of A and C is equal to 0.2. Yes. There you
Oh
see.
yeah.
Because
I
otherwise,
think-
probability of B given A and C should be the same.
Yeah, the thing is, the thing is, A and B and A and C and B and C are independent, but
not all together.
Communication or the combination of them are all dependent.
Oh.
That's so fucking tricky.
So if this said B given A and C, if that was 0.4, then it would be...
Yeah.
Yeah.
Fuck me, I thought, okay, yeah.
So fucking evil.
That is
Not
evil.
fuck me, fuck them.
Fuck them as well. Alright. Okay, well then we know. So we know that A and B are independent, B and C are independent, A and C are independent, but A, B, and C are dependent, so it's B. We would have had that one wrong, but that's alright. We now know why.
Yeah.
Okay, so now we have P of F of A. This capital P, what the fuck does that mean?
Where?
This one.
The chance. It's just a weird way to write the normal B.
Yeah.
The chance of X.
It's the PP.
The chance of X equals E squared.
Okay, but this is the distribution function.
Yeah. So the chance that X equals E squared is the distribution function. No.
No, it's the derivative of this thing.
Difference between the. Yeah. You can say that. You can also say the difference between that one and the next one.
Well, but it's not discrete.
Yeah.
Continuous.
Fair, true.
Okay. So let me zoom out one bit more. I want to zoom in more than this, but less than this. What do you mean? Whatever, this is good enough. So we have this whack-ass function. And we have to take the derivative from this.
Yeah.
Wait, no.
No, wait.
You just
This-
have you just
this is
multiply the
discrete.
length.
This
the
is discrete,
length.
isn't it?
No, it's not.
No, it's
Oh, wait.
three
Wait.
distinct
Zero.
formulas. It's
No, it's 0. It's continuous function. Chance of x is something is 0.
Wait, hold up. Hold up. Why is it not discrete? Because if wouldn't it be if at 0.1? Or hold up. No, yeah. Else it would be a normal value.
no, but it doesn't give the option for one is 0.
But we know.
No, yeah, no. This makes complete sense. It's discrete because so at the point 0.1, or at the point. Yeah, so lower than 0, it's 0. Don't look at that. Between 0 and e to e, it's 0.1, meaning that at 0, the mass function is 0.1. Like, draw the shit out. You'll see. Draw the shit out.
This is the distribution
Get
function, so it starts at 0 and ends at 1, basically.
This is discrete.
Oh, yes,
Gee,
I see.
looks pretty fucking discrete to me.
Yeah, no, okay, that makes sense. So p of x is equal to e squared is just equal to 1/4.
Yeah.
Yes, because we are looking at the increments of this thing.
Yes.
No, it's not in fourth. It's 0.1 plus 0.4, 0.5.
What?
I think no. Wait, that's not an option. Never mind.
Yeah.
You're right.
So it is 1/4.
Yeah.
So I equal 0.25.
The chance that it's greater than e to the. So 1 over 4.
Is greater than e to the 1 minus 1.
That's 0.9.
Yeah, but that's just this thing. It's just like.
No, it's all the ones after 0.1
just this
added
thing.
together.
Yeah.
So that is this jump plus this jump
Plus
plus this jump then.
Which is 0.9.
0.9.
So it's B.
B.
Yes.
And we
Big
have
brain.
to be
Called it
just
discrete.
imagining.
Okay, let x and y be two random variables taking on the unit interval with joint density this. Compute x between this part and y between that part, and are they independent? Well, this is like the first question is really easy, so I'm going to focus on that one first. So we have the integral from. Can I say 0.1 here? Will that let me? Probably not. No, figured as much. From 0.1 to
LaTeX making it easy? I don't
0.3
think so.
of the integral from 0.6 to 0.8 of x plus y dy dx. Let me put some brackets around that to make it more clear what we're doing. Okay, so first we have to take the derivative with respect to, or not derivative, antiderivative with respect to y, which will turn this into, oh boy, it's almost as if we've done this one before. Xy plus 1/2 y squared. Evaluated from, this would be a really fun question if they didn't have such fucking annoying bounds of integration.
Yes.
Okay.
Dutch flag.
So this becomes, actually I'm just going to rewrite them as fractions because that's easier. This is 6 over 10 and this is 8 over 10. Okay. What a fucking mess. So then we do top minus bottom. So top minus bottom. Top is 8 over 10. This is going to be 8 over 10x plus 1/2 times 8 over 10 squared, which will be 64 over 100 times 1/2, which is 32 over 100, minus, and then we take the other one. This is 6 over 10.
So this will be minus 6 over 10 plus 1/2 times 6 over 10 squared, which is 36 over 10 over 100, which is 18 over 100 when you factor in the half. Again, this is a subtraction, so we subtract 6 over 10x from 8 over 10x, which will turn into 2 over 10x, and we will subtract 18 over 100 from 32 over 100, which will turn this into 14 over 100. Okay, so then this is our next integral. And again, I'm going to turn these two into fractions as well. So it's fraction of 1 over 10, fraction of 3 over 10. Okay, then taking the derivative of this becomes this thing with x, this thing becomes 1/2 x squared. I can get the 1/2 into the 110 here, or 2 over 10, which becomes 1 over 10. So then we have this thing evaluated from like this. Okay, then we take top minus bottom minus bottom. So the top is 3 over 10. So here we have 3 over 10 squared, which becomes 9 over 100, times 1 over 10 becomes 9 over 1000, plus 14 over 100 times 3 over 10, which becomes 14 times 3 over 1000. Shall we calculate in a little bit? Just getting my notes straight. 3 times 14 is equal to, what's that, like 42? Yep. Guys, the funny number of mathematics. Haha. Then we will have, is that correct? Yeah. Yeah, so we do end up with things in 1000 on all sides. And then we subtract from that the bottom, which is this. So 1/10, which at least these calculations are really easy. Then 110 squared becomes 1 over 100. So then these are the final numbers. And now to actually calculate them. So we get 9 over 1000 plus 42 over 1000, which makes 51 over 1000. Then from that we subtract 1 over 1000, which becomes 50 over 1000. And then we subtract 14 over 1000, which becomes 36 over 1000. I really hope that's a fucking answer, because I'm going to scream if not. Yes, even better, there's two answers to that. Now we have to figure out if they are independent. Finding out if a continuous random variable is independent, or if two continuous random variables are independent, is as easy as saying, let's
Wasn't it
see.
just integrate over the entirety of x and seeing if it's the same?
Hmm?
Or something? Wasn't it just integrating over, like, if integrating away one of the variables and then seeing if the joint thing is the same?
Yes, makes sense. So, like, as per usual, we have f of x times f of y is equal to f of x comma y. So this should be true for some, for some variables, for it to be randomly independent, or for it to be independent. And this becomes fxx, this becomes fyy. So let's figure those out. Again, if we figure out one, we need to figure out both of them. So then we have to take the integral. This one is unbounded from, this one is unbounded from. So the integral of x plus y dx is equal to 1 over 2x squared plus yx. It should be from minus infinity to infinity, my bad.
Okay, and again we're differentiating or integrating away x. So this is fy of y.
Yeah, and it goes from 0 to 1 instead of negative infinity to infinity, because that's the bounds of the thing.
Hmm? Oh yeah, with so these bounds again, like I will actually say it like what I'm saying is correct too, but it's then this is equal to, and I will actually write take a new line for
if
this.
you use negative infinity and infinity, it won't make much sense.
Yes. But like these two are just mathematically equivalent.
Yes. Well, if you're looking at this domain, then yes.
Yeah, like for this function. So the lower bound is 0, upper bound is 1, and this is from 0 to 1. And again, it's top minus bottom, so we basically fill in 1 for x here. So this becomes 1/2 plus y. Okay, same thing, because we can say without loss of no, that's not the right word. But either way, f of x is equal to 1 over 2 plus x. However, f x x f y y is equal to 1 over 2 plus x 1 over 2 plus y, which is not equal to x plus y. Therefore, we can say, or which is equal to f x and y. Therefore, we can say that these two are dependent. So we know that the answer is they're not independent, so they're dependent, so the answer is C. At least it's.
I feel like this, like, it's probably correct. It just feels a bit weird, but sure, it's probably correct.
Why does it feel weird?
I don't know. Can you show me the slide where it says fxx fyy equals fxy then?
Oh yeah, sure. So I think we're already in the right one even. So I have to go up a bit. So these are independence, yes. So the independence of a does it just skip over it? Maybe it was in the pre-lectures.
Independence of the random variables images.
Yeah. So these are this video is about the independence of random variables. Yes. So this is. We already knew this one. Here. You see? So here it says for continuous random variable, it says fxy is equal to fx of x, fy of y for all x and y.
Okay.
Cool. So then, we know that it's C. A certain brand of copper wire has flaws about every 60 centimeters. If we model the location of the flaws by a Poisson process, what is the probability there are 3 flaws in 1 meter of wire? Okay. So we have X simulates a Poisson of 60 And
0.6, I would say.
So yeah, Poisson. So one time interval is equal to in one time interval the
The expected value per 60 centimeters is 1. In the next 60 centimeters, how many do we expect to get?
Yeah, so
if we extend that now to 1 meter, then it's 1 times 5/3 or 1.666 repeating.
So we have 1 times 1 divided by 0.6. So that's 10 over 6. So this is, or that's 6 over 10. So this is 10 over 6.
Yeah, 5 over 3.
Yep. Okay, and what is the chance of there being? What was the question?
Exactly.
That there are 3 flaws in 1 meter of wire. Well, then we just have to take P of Z is equal to 3 is equal to, again we're doing
5
Poisson, so
thirds
that is the fraction of
5 thirds to the power of k.
a fraction of 5 over 3 to the power of k over k factorial times e to the power of minus 5 over 3.
Yes, and then we replace the k with 3.
Yes. So then we get this to the power of 3. 3 factorial is 6. Okay, this thing to the power of 3 is equal to 125 over 9. When we take this thing and divide by 6, the same as taking the bottom of this fraction and dividing that by 6, or multiplying that by 6. Then we have 6 times 9, that is 54. Then this is our answer, and then we can basically approximately calculate this.
Oh, we can exactly calculate this with our
Yeah,
calculator.
exactly, but
Technically, it's not exactly
okay.
because
So we have
Yeah, I was gonna say technically it's an exact.
e to the power of opening bracket minus e.
You have to use the button. Remember, you have to use the button for the power. Otherwise, it doesn't work.
Opening bracket. Yep. Minus. You have to use the button for your power. I believe you.
You have to use the button on the calculator. You can't use the keyboard shortcut.
Yeah. So e to the power of opening bracket minus. Okay. 5 divided by 3. Closing bracket times what?
Yeah, or
no, I clicked the wrong button.
Just get a physical calculator.
Opening bracket minus 5 divided by 3 closing bracket times 125 divided by 54 is equal to 0.43 something. None of the answers.
There are exactly 3 flaws in 1 meter of wire.
What is the probability that there are 3 flaws in 1 meter of wires? Did I fuck up my calculation somewhere?
That seems reasonable.
Okay, let me retry that. So we have p z is equal to 3 is equal to the fraction of 5 over 3 to the power of k over k factorial times e to the power of minus 5 over 3. Like this is factually correct.
Yes, that should be factually correct with our mu equals.
Okay. So then we fill in 3 factorial, that's 6. And then we fill in 3 here, which turns this into a 9. No, this turned into 26. 27. Fuck, that's a mistake.
Yes.
And this becomes 125. There we go. And this becomes 27 times 6.
So just take your
162
your
by the way.
Take your final answer, just divide by 3.
Hmm?
Just take our final answer and divide by 3 and it's fixing it.
That makes sense. So then we multiply this by 3. What did you say? 162?
126. Oh wait, no, I
No.
was wrong.
54, that becomes
162,
162,
never mind,
correct.
162.
Yeah, 162. So that was correct. So then we fill this in our calculator.
Just divide by 3. You could have just divided by 3!
He cleared already, too late. Wait, you can look at the history, never mind.
No. 1,
6,
2 times opening bracket e to the power of opening bracket minus 5 divided by 3 closing bracket is equal to 0.14. It's B.
Well, it's technically 0.15.
Yes, but this is the closest answer.
That's a rounding error, I think, because I got 0.14.
Okay. 8b. 9. For some p in the closed interval of 0 to 1, let x be a geometric distribution of p and y be a geometric distribution of p minus 1 be two independent random variables. Compute for k is bigger than 2 the probability of x plus y is equal to k and the expected value of x times k. Let's see.
X times y.
Sorry, x times y, my bad.
Wait, our midterm isn't going to be entirely multiple choice, is it?
No, definitely not. Our midterm will be on Graspel, so.
Yeah.
I think ours will like be almost only open answers.
Yeah, I think it'll be entirely open. With the exception of some questions.
Which fucking sucks.
No, I guess. There'll probably be like 2 non-open and all the rest will be open.
Yeah.
No.
I think that, but I think there's less questions this time. I think there's something like there's 10 questions or something.
Sounds reasonable.
Okay, there's 16, yeah.
Yeah.
So we're halfway there in an hour, so that makes sense.
Okay, we were on 9, weren't we?
Yeah.
Yeah.
So we have a geometric distribution with p and a geometric distribution with p minus 1.
Okay,
One
now
minus
I've
p.
been queued. Guys, you can queue for the SQT midterm. Oral check.
Ah, nice.
Oh, it's in queue.
Yeah.
Now that's a thing I haven't used in a long time.
Same.
Yeah, I will do that after the thing.
I wasn't even enrolled in quarter 3, I don't think.
Yeah. I'm not enrolled for quarter 4. I have to find it first.
No, if
Why
you open the
you
link,
search-
if you open the link in announcement, it'll show you how to enroll.
Okay.
Okay.
That's much easier.
All right, so we have the geometric distribution of p and the geometric distribution of 1 minus p. Oh, that's interesting.
You can also queue for the 27th of May now.
How would we go about solving this?
How would you go about doing what?
Solving 9.
Okay, so the probability of x plus y is equal to k. So
the probability of x plus y being equal to k.
x is how many successes or how many failures until success. Y is how many successes until a failure, effectively.
Yes.
So those two are opposites of each other.
Yes.
Yeah.
So for any one number, what is the probability that you have?
No, you can't do that. K is greater than 2, and we just have to use the formulas we know to determine this.
Do we know any formula for this though?
Yeah, from the formula sheet for geometric distribution.
Yeah, like this is the geometric distribution formula.
Px equals and we have to use that for x plus y equals k.
Yeah.
So we have the joint distribution of x plus y.
How would we calculate that? I'm getting a bit like brain delay. Give me a sec. So
it's basically k minus y. X equals k. K and k is equal to k minus y.
What?
what he's doing is he's subtracting y on both sides.
Mm-hmm.
Which makes it a bit more. Basically, we know. Yeah. What he said, basically.
To be actually equal to k.
So you want to move y? And we know what y is.
Well, yeah, y is.
Yeah.
Okay, wait. Let's see. So p of x is equal to p times 1 minus p to the power of k minus 1. That's an L, not a K.
Wait, hold on. Can you go to the question real quick?
Sure.
Thank you.
P of y is equal to k is equal to 1 minus p to the times p to the power of k of k minus 1.
I'm gonna be fairly honest. I would
Yeah.
take p is 0.5 and start like doing maths with it, checking which one would work. Because this sucks ass.
On multiple choice, but not on this year's.
Yeah. So we wouldn't get. You would get away with that on this one,
We
but
would not get this question.
So let's see. We need to. Like, I'm tempted to just add them together, but it doesn't work like that.
No, yeah.
I see a lot of bullshit with this 1 over 2p factor, but
Can you zoom in a bit more on the answer sheet or the exercise sheet? Because yeah, thank you.
How is this not?
1 minus p squared. Oh.
Let me. This one should be a bit more zoomed in.
I'm just thinking how the fuck they would even get to this, like, equation. Because this is horrible.
Okay, first of all, we can eliminate some of the answers. So we know that we can start out by calculating the expected value of xy. So let's see. We know that the expected value of x is equal to 1 over p. We know the expected value of y is equal to 1 over 1 minus p. And we know the variance of x is equal to this thing. The variance of y is equal to that thing, but then inverted. So let's write that down as well. Variance of x is equal to. I mean, I don't know. Actually, never mind. There's not much.
How useful it is. No. Not sure how useful it is.
Yeah. However, we know that they are independent, so the covariance is 0. So covariance of x comma y is equal to e xy minus e x e y.
Well, the simple question here that we have to ask ourselves, is it going to be 1 over or is it going to be not 1 over?
Well, we can figure that out, right?
Or 2.
Because we know the covariance.
That's all we need to want.
Yeah, I know, but I'm going to calculate that. So the covariance here is going to be 0 because they're independent variables.
Mm-hmm.
So we know that this thing minus this thing is equal to 0. Therefore, we know that exy is equal to
EY.
EY.
Which is equal to 1 over p, 1 minus p.
Yeah, so we can say it's,
that
it's
means it has
one
to
of
be
it's
two,
either this one, or this one.
It has to be B, E, or F.
Yes.
F.
out of that one, I would. Hmm.
Okay, let's do funky for a second. Let's say P is half, K is 2.
Okay, well, let's first of all, one thing. F is if you just multiply x and y. That one's
Yeah.
simple to see.
Yeah, I have no clue how they got the rest.
Yeah, like I don't know how they got like even close to this. What happens if you multiply it out?
Hold up, Jura.
Yeah.
Oh, it can't be E. Wait, hold up. I don't think it can't be E or B.
Why can it not be E nor B?
What happens if P is a half? Look just at the denominator.
-2, 1/2.
Yeah.
That's 0.
That's 0. It can't be 0. It's F.
Fuck you, it's F.
That's actually
you got
pretty.
that, Brit.
You are big brain.
Jesus fuck, that is big brain.
Yeah,
I mean,
okay, real quick, I just want to be sure, but I like.
Yeah. These catty's ears really must have a good effect on your brain.
Fuck. Oh wait, no, it's not. It's 9.
It's E.
Ha.
How is it E? How is it this thing?
Oh, probably because if you fill in the half, the top will also be 0.
Yeah.
Hmm. How though? How will you get there?
Not a clue.
One minus 2p? What the fuck?
I don't. I hope we won't get it as something bullshit like this.
Okay, well, let's.
Yeah, the top will also be 0 then. That is wonky as shit.
That's wonky as fuck.
Yep, no clue 10.
Yeah, let's just honestly continue.
One mistake on the test is still a 9.8.
Fact.
They actually had 9.4. What's 1 divided by 1.6?
Alright then. Research shows that out of all Europeans who drink soft drinks every day, 1 in 4 is overweight. Oh.
Not me, hey.
Underweight gang. A is or let's see. S is drinks soft drinks.
That is some nice obfuscation we've got going on down there.
Yeah, damn. Stream just was like, no.
You want me to restart my stream?
No, it's fine.
No, it's fine. It will fix itself.
We have
Okay.
someone in the comment, Kiki, and that's
So we have this.
I don't know what you're talking about.
So let's see. Out of all people who drink soft drinks, one out of 4 is overweight. So we say P if you're overweight, given that you drink soft drinks. I'm gonna say D for drink soft drinks. Is equal to 1 over 4.
P, I will laugh at you, given you're overweight is 1.
For people, that's fat shaming. For people in Europe who do not drink soft drink on a daily basis, there's only 1 in 6. So P overweight given does not drink.
Does not drink, just dies.
Yeah, he fucking dies because you should drink at least like 6 big glasses of water a day.
That's wrong.
I don't know. I just pulled a number out of my ass.
I know.
Apparently, 25% of Europeans drink soft drinks every day. So, D is equal to 1 over 4.
I can say I used to be one of them.
Ha, I don't. No, I just chug energy now. What's the probability that a European drinks soft drink every day, given that they are overweight? What the fuck would you... Given that S or he... Fuck off. Given that they are overweight. So we want to know if they drink soft drinks, given that they are overweight. So let's see. Well, this is all
Maybe
not that
zoom
hard.
a bit out so we can see the entire question text at the same time.
Is this a slider? No, it's not. That's annoying.
Why is it not a slider?
Grr. Yeah.
So I think we had all the information out of the question. Okay, now we can start calculating. So we know PD, we know PO given D, so then we can say PO cap D is equal to PO mid D times P of D is equal to 1 over 4 times 1 over 4 is 1 over 16. So let's see, we can also, this is our overweight and a drink. That's same as, oh yeah, okay, so this formula makes sense in my head. Always important, we have the P of D's complement is equal to 3 over 4. I expect not to have to go into detail about that one. Then we have P of O cap D's complement is equal to P O mid D's complement times P of D's complement. Then you can P of D's nut. So that's equal to 1 over 6 times 3 over 4. That's 3 over 24. Okay.
Still, the mental gymnastics people will go through to avoid using they them.
Exactly. Ugh. All right. So now we know. Yoink. Yoink.
Jure.
Hmm?
I hate trans people. I would never use singular plural pronouns for them.
Yeah.
When you're a transphobe, you really sound like this. I really shouldn't have picked letters that are so alike. Whatever. So
We don't sing for-
Oh, wait. So we know. Okay,
You
wait.
know
What do we need for this, right? This is just PO given D divided by PO. So then we need P of O.
Ooh.
Well, we know the fact that, like, we know this part. We know this entire part, but that doesn't help us. So everything except for D. We know D. We also know O and not D. So that is. Oh wait, O and not D. That's like this part. Therefore, O and D plus O and not D is equal to O. Yeah, that makes sense. P O cap D plus P O cap D's complement is equal to P of O. Yeah, that makes sense, because we have this region and this region. And then we can say it's equal to 1 over 16 plus 1 over, or 3 over 24 is equal to
3 over
what, like
16.
2 over 16? So that's 3 over 16 total. 3 over 16. Okay, and now we have PO. And now we know that PD given O is equal to P O and D. So that's this one. Divided by PO. So then we have this number divided by this number, flip it around. That becomes 1 over 3. So the answer of this thing is equal to 1 over 3. Probably went a little fast, but I hope you guys understand the step. The answer is then F. Okay, up to 11. Let x be a continuous random variable with this density function. Find a and b bigger than 0, knowing that the expected value of x is equal to 3 over 5. So we know that basically what this question is giving us is that the integral from 0 to 1 of a plus b x squared dx times x, because it's the expected value of x, is equal to 3 over 5, and also the integral from 0 to 1 of a plus bx squared dx is equal to 1. Because again, it's a probability density probability density function, so this should hold always.
we focus on the second one first? I think they'll eliminate many of the possibilities.
Yeah, I think so too. So,
I mean, technically, I believe it is solvable with just the first one. But...
Hmm?
Actually, it might not be. Never mind.
It's
Yeah.
not, I don't think.
Okay. Yeah, let's just do the first one. So this will give us ax plus b 1 over 3 bx, or let's say b over 3 x cubed. From 0 to 1, so it's top minus bottom. These both have a factor of x, so this is just the same as saying 1. So a plus b over 3 should be 1. Okay, let's see. A plus b over 3, so that should be 6 over 5 plus 3 over, plus 1 over 5 is equal to 1. Wrong. D, so that's this thing over 3 should be 1. Wrong. B, 6 over 5 plus 0 is 1. Wrong. 2 over 3 plus 1 over 3 is 1.
You, sir, are correct. But let's see the other ones first.
Yeah, but let's just write it down so we know. Then we have 3 over 5 plus 2 over 5. So it's
1.
Yeah, that's 1, so it can also be C. 2 over 5 plus 1 over 15. No. So it's either E or C. Okay. Then we can work out the first one. So that is just equal to 1 over 2. Actually, it's A over 2x squared plus B over 4x to the power of 4. Is
3.
equal to 3 over 5.
3.
No, 4. Because we multiply this x inward.
Oh yeah, true.
And then again, filling in 1 for x gives this. So let me wait for it to re-update. Yep. And now we can have a look at E. That will be 2 over 3 divided by 2 is 1 over 3. And 1 divided by 4 is 1 over 4. I do not believe that 1 over 3 plus 1 over 4 is 3 over 5. No, it's like 7 over 12. So then it must be C, but let's check that out first. Yeah, that totally makes sense. So, yeah. So it's 3 over 5 divided by 2, plus 6 over 5 divided by 4. That's the same as saying 3 over 5 divided by 2. So then we have 2 times 3 over 5 divided by 2 is 3 over 5. So the answer is C. Okay. The number of traffic accidents, x, in a unit interval of time is modeled by a Poisson process with density lambda. Determine the probability. Okay, whatever. Determine the probability of the event that there are no accidents in 0t and precisely 1 accident in 3t to 4t. Okay. Realistically speaking, yeah. So what this is saying is since there are no accidents in 0 to t, and there's precisely 1 accident in this time, these two things are physically independent, right? And when you're using an AND with physical independence, or just any independence, you can multiply them together. So we have to find probability 1 times probability 2, and then we can know what 1 is. So first of all, we have a Poisson. Let's say x simulates a Poisson from 0 to t, or with intensity lambda. Let's see, so let me grab the Poisson. So a Poisson with lambda. Is it Poisson or, yeah, huh. Cool. So it's Poisson lambda. And a lambda is it's a discrete thing. So we can, say px is equal to k is equal to lambda
to the power of k over k factorial times e to the power of minus lambda. And again, because this is a thing over 1 unit of time, let's see, so we have over t units of time, and here it is also t units of time. So let's see, how do we convert this to t units of time? How the fuck is this a Poisson? All this shit looks like
Exponential is Poisson, but then
No, but number of
zero.
occurrences in a time interval is Poisson always, basically.
yeah, okay, but it looks a lot to me like exponential, but it makes sense.
Yeah, they can be close, but
Yeah, they are pretty close. Either way,
well,
let's
wait,
see.
find
So
the
we want to
Poisson.
find the chance that there are no accidents between 0 and t, while our current time thing is modeled with 1 interval. So to go from 1 interval to t intervals, so we can have a function z that simulates Poisson of lambda in t. I'm just going to call them seconds instead of intervals because it makes more sense. Then we have p of x is equal to k. So this should be lambda to go from 1 second to t seconds. Do I just multiply it by t then? Yeah, right? Yep, that makes sense. Because we're having t intervals of 1 second. So then the probability of x, or in this case z is equal to k, is equal to the fraction of t lambda to the power of k over k factorial times e to the power of minus t lambda. Okay? Okay, this makes sense. So then we have there are no accidents between 0 and t. So this is just p of 1 and precisely 1, or sorry, p of 0, and this is precisely 1 accident in this thing, which is p of 1. So then we can say, since they are multiple, since they're independent, we can multiply them together. So this is equal to p of z is equal to 0 times p of z is equal to 1 is equal to, let's see, p of z equal to 0 is equal to the fraction of, so let's see again, this is k is equal to 0. So the first half will be 1, and then we'll 1 e to the power of minus t lambda. Let me put these down so that it stops complaining. Yeah, and then we do that multiplied by the fraction of t lambda over 1. Well, I mean, I can get rid of the over 1 times e to the power of minus t.
Should be a space after the lambda.
Lambda.
I'm just not sure if it counts lambda as lambda e or if it goes haywire.
Oh yeah. And this thing here should be like this. So we have the probability of p is z is equal to 0, z is equal to 1. Again, these should be two different sets because you can't have the chance of something being 0 and 1 simultaneously, but you get what I mean. So this is what we get. Therefore, this is equal to T lambda.
Well, you can't have P z equals 0 and z equals 1. You can have P z equals 0 times P z equals 1.
Yeah, okay, that's true. And then so we add those two up, so that becomes e to the power of minus 2t lambda. Yeah, that seems to make sense. Is there an answer like this? Yep. So this is either A or C. Or
oh yeah.
Yeah, no, A or C.
Yeah. Number of accidents in the interval 0t.
Yeah. And the mean number of accidents in the interval 0 of t. So since our Poisson distribution is now
T lambda.
Yeah, our input is actually lambda t.
Yeah.
So actually our expected value is also lambda t.
Oh.
Wow, cool. So the answer is A.
I would agree with you.
I'm 100% ready to hear that I'm wrong.
Yes, Poisson distributions suck ass.
Yes. The number of minutes.
I like Poisson. Poisson's nice.
I like that. I am less angry at them now that I've realized that taking the Poisson distribution over a time interval t is the same as taking t different Poisson distributions over a time interval of 1, meaning you can just multiply the input with t.
Yeah.
And that has made stuff a bit easier. But they have definitely under-explained it, in my opinion.
Yeah.
Anyways, let's continue.
I already knew what Poisson was, so I didn't have that
helps.
problem.
Yeah.
Also, it has a fun name. It's just fun to say Poisson.
Oh, huh. Bitcoin dipped with 12,000 euros just now. Interesting.
Like they say.
Lul. Hey, it's a good moment to buy. The number of minutes your next year leads to grade your midterm has a what's it called? Pareto distribution. Distribution. What is the probability that your lecturer needs more than 9 minutes to grade your exam if you know that he/she needs at least 4 minutes?
Just use fucking they.
So we need.
What if your lecturer is MBA? Fuck faces. Think about that.
Yeah.
Thanks.
P of x is bigger than 9, given that x is bigger than 4.
What? Oh.
Yeah. They need at least 5 minutes, at least 4 minutes, and we want to calculate the probability that they need more than 9.
Isn't that just p equals 9 divided by p equals 4? Because p equals 9 and 4 is just the same as p equals, or p larger than 9.
Yeah, let's actually write this out. So we have to. This thing is equal to the fraction of p of x is bigger than 9 cap x is bigger than 4 over p x is bigger than 4. Okay, and again, as you said, the chance of it's being both bigger than 9 and bigger than 4, same as the chance of it being only bigger than 9. All right.
I still have a notifications for my ADS implementation end-term oral check. Oh my key.
Again, so they're Pareto distribution. Okay, and we are probably just going to use this one. So we know that p x is less than or equal, or let's say less than, because continue with blah blah, is less than x is equal to 1 minus x to the power of minus 3 over 2. Therefore, the chance of
x being bigger than x is equal to 1 minus x to the power of minus fraction 3 over 2 is equal to, and of course there should be brackets here, is equal to x to the power of minus 3 over 2. Okay. So now the answer to our question will be 9. Oh, I forgot a closing bracket there. Over here. 9 to the power of minus 3 over 2 divided by 4 to the power of minus 3 over 2.
What a fun answer.
What the fuck?
Beans, what the fuck?
Okay, wait, I fucked up my bracket somewhere. So far this is correct. The fraction opening of 9 to the power of minus blah blah blah. Opening rate 4. So there should be 2 here. Why is that not correct? Oh, file ended while scanning for a fraction.
Yeah, you don't close off your fraction at all. Like you start it and you do nothing with it.
Which one? This one?
Yeah.
Oh, yeah, there should be one more here.
And I don't think you have a second one either. Oh no, you do. Never mind. That's fine. Is it? I think it is. Yeah.
So it's this thing. All right. Give me 1 second. I will be right back in approximately 5 minutes.
Up the cameras, that ass.
So how's your day been? Not at once, not at once. Calm down, calm down.
I said,
Well, pretty good, bro. What about you?
That's been decent. How are you guys feeling about the exam? Think you're gonna be able to pass this one at least?
Yeah.
Sure,
Yeah.
it's gonna be fine. God, I did the thing. I'm now installing about 20 mods for KS. No, 30 mods at least.
Let's see.
40. I think 50 mods for KSP I'm installing right now. Wait.
I'm also quite confident that this should be possible.
Yeah.
Like, I'm not going for a 10, because I mean, I'm going for a 10, but I know for myself that every time I go for a 10, I'm gonna get a 6.
Possible. Possible. PAW-sible. Oh no.
I'm thinking I'll probably get a 7.5 for this exam, because there's like, it's open questions. That's like the large thing. I'm thinking for every multiple choice question exam, I can probably get like way higher. Because my problem is not in the is never in the guessing or in the knowing what to do. It's in the execution. Generally, that is. Luckily, we have a calculator to check our answers. And what I also like is that with the matrix stuff, is just yes, this output matrix. There's no way to check if this is correct. And here, there are many ways to check if it's correct. Like just if you get a distribution, plug in some numbers, plug infinity, plug in negative infinity. If you get a chance, is it 0, 1? Is it about what you expect it to be? It's very easy to catch runaway math errors if you have an answer here.
I see we went on the graph plotter raid.
Yeah. Is your math error running? Well, you better run after it.
Oh God, I did the thing. Why do I do this?
Okay. Oh wow. Okay, I see how this could be easier. So we know this is actually 3 squared.
Oh, wait, isn't it 3 over 2 to the power
So that means this is.
It's 1
we can
over.
multiply these two numbers out.
Yeah, 1 over 3 to the. 1 over 3 over 2 to the power of 3.
So I can get rid of this one as well.
You can also think of it as
2 over 3
to the power of. If it's to the power of 1.5, it's just that number times the square root.
I think it's e.
So
We'll see. We'll see.
So now we have this.
Yeah.
And actually, this makes a lot of sense. Okay. So what we're doing here is we're actually saying frac. Well, this minus sign should mean that this one goes to the bottom and this one goes to the top.
Yeah.
So this is just 2 to the power of 3 divided by 3 to the power of 3.
I fucking love Bernoulli trials. They're so dumb.
Do something like once, do it again. Cool.
Yeah, it's like
fucking do it
the most
again.
basic trial you can ever have.
Yeah, Bernoulli trial is like, I heard the word, I was like, oh no, and then I saw what it was, and I'm like, oh yes. So this is, let's see, this is 8, this is 27, so it's 8 over 27, so it's E.
Imagine fucking being Bernoulli, like spending your life devoting it to maths, and you're the only way people remember your name is by flipping a coin.
Okay.
Isn't it 13?
No.
Hold up.
It is 13.
Yeah.
People remember Bernoulli for other stuff.
Like? That's what I thought, huh?
This question, like,
okay. If A is an event with the probability of A, we denote XA is a Bernoulli of probability of A. Assume A and B are two events with probability of A and probability of B are both bigger than 0. And P dot comma dot denotes the correlation coefficient. Which of the following is true? The correlation coefficient. Oh. Okay, I'm gonna write out a bunch of shit.
Let me put it simply. Bernoulli probability is a small thing. Bernoulli's in aerospace is massive.
Yeah, we don't do aerospace here.
He is literally the foundation of planes.
Yeah,
Okay.
we don't care.
Choose the planes.
No, the foundation of planes is actually what's that Italian guy called? The one who invented planes?
Euler.
No, the one who invented planes.
Right.
Yeah, the brother's right.
Oh yeah.
They invented planes.
They were American.
The famous Italians, right and right.
Yeah, okay. I was close though.
No, you weren't.
Fun fact:
From the
Euler,
Italian
on his
state of
birth
New
list,
Jersey.
released about one scientific paper per month.
Okay. So this is the expectation of XA and the variance of XA.
Hold up, how do you pull that out of your ass? Just look at the Bernoulli things? Or?
Yeah, it's literally here.
Okay, you just write P as PA. Sure.
Yeah, because they say that P is probability, you know, here.
No, and for Bernoulli, PA is P.
Okay.
Yeah, I was
so it's one of these is true, okay? So we know the variance. Okay, let me first check if any of the bottom ones are true. So we know, is there like rho x underscore a x underscore x underscore b is equal to. Okay, so this is usually given by the covariance of xa, xb over the square root of the variance of xa times the variance, or times the square root of the variance of xb.
Ooh. There's one thing which is going to be at the heart of this. Are A and B independent? I don't think they are they?
Well, yeah, they are. They're two there are two events.
Yeah.
Like a Bernoulli trial is really hard to be dependent.
No.
I would say no.
Well, okay, that's fair. It depends which Bernoulli trial.
Like, I don't think they're independent. So, like, the thing is, so the D or C could be true if E of AB equals P, A, and B. I believe that that is only the case if they're independent. Is it not?
Let's see. So let's do some more. Let's do some more logic and writing stuff out. So we have the covariance of XA, XB is equal to expectation of XA, XB minus expectation of XA, expectation of XB. However, we don't know this.
What the fuck is the expectation of a complement? That would be
like the question is, is so E of XA is PA, but I don't think we can say that E of XA XB equals PA and B.
Well, actually, so let's see. The expectation of a Bernoulli trial is P. Okay, I know how to get the expectation of adding two Bernoulli trials, but that makes sense.
So,
but
if
But
you
what-
no, never mind.
What's the expectation of the complement? That 1 minus, I suppose.
I think it would be more fruitful if we looked at A and B first.
Sure, that's what we're doing anyway. So
That is what we're doing. But what is the expectation of B complement? That is the simple. That is,
let me first actually write out this stuff.
Sure.
So we know these two, right? So we know the expectation is, in this case just P A B B.
I'm nudging towards A, by the way. Just saying. Like just logically speaking, the covariance of the one while looking at like one and the negative of the other, like all the trials that didn't make the cut at the first time should be the negative of the previous, whatever. So instead of B, you have 1 minus B.
Yeah.
What would that give us?
So you're looking at this one, okay?
Yeah, the top one.
So, copy, paste. So this will be the case when we're looking at B's complement.
I think so.
Oh, I should put brackets around this. And also put brackets around this.
okay, time to test out KSP with 50 mods.
Okay, so let's see. The covariance of A, B's complement is the expectation of A, B's complement minus the yeah. It does not make much sense for B. I think B is false.
No, it doesn't. I think at the heart of this is going to be that E X A X B. Like, what can we think up about that?
But
let's have a logical thinking thought about like the expectation of a Bernoulli trial, right? So the expectation of a Bernoulli trial is the number because it's going to be 1 with a chance of P and 0 with a chance of 1 minus P. So if we have 2 Bernoulli trials, then let's actually draw this out. So we have a 3x3 table here. P A and 1 minus, or actually let's say X A is 0, X A is 1, X B is 0, X B is 1. So this thing only happens.
That is AB.
Hmm?
AB. A times B.
B.
Small a times small b, basically. Probability of A.
Yeah, so it's going to be P of A times P of B. This is going to be P of A
times 1
1
minus.
minus P of B. This is going to be P of, or 1 minus P of A, 1 minus P of B.
But this is assuming
And this-
independence.
True.
Yeah.
They don't ever say that they are dependent.
Yeah,
They don't
I don't
say
think
that
we
they are
can. I don't think we
independent.
can do this question if we don't assume independence.
No, but like we shouldn't assume independence. Then
We
if it's
should
not
not.
independent, then I would rather take A because of its logical implication, than assume independence and just go completely off the rails that way.
But okay,
Because if you look at A, like, huh?
But what is B complement? What does that mean then? Is
B
that
doesn't
1
happen.
minus what? So that is 1 minus B.
Yeah.
Mm-hmm.
1
So
minus
just replace do the covariance and replace. Yeah. Okay. Yeah. You replace with.
That's what we did here.
Mm-hmm.
It does not make any sense to me that this will eventually turn back into a normal covariant function. I do not think A or B or A
I
or B
never
is true.
mentioned. Does it say anything about B being a fucking
Bernoulli?
Yeah.
Where at the right of this then?
A and
No.
B are two events with.
No, but is B Bernoulli? No.
No.
So we can't even say anything about B then. All we know is that A is Bernoulli.
Well, what's the formula for the correlation coefficient? Because that is the covariance over the.
This one.
Yeah. So let's see. How does the variance? Probability of A and B minus PA.
Well, like the thing is, we can't say anything about PB this way because B is not Bernoulli. So.
Well,
PB
it's
could be like any number.
like I think it's D. I'm pretty sure it's D. Or no, because
that would mean that E
variance
XA XB would be P A and B, and that is highly doubtful in my opinion.
What do you mean that the EX
E XA XB
yeah
will be P A and B?
Yes.
I doubt that. That would be that requires independence actually.
Well, yes, but that is true at the very least for Bernoulli's. For Bernoulli's, that is true.
For independent Bernoulli's.
Yes.
But
So
they're not
let's
independent, and they're not both Bernoulli.
Mm-hmm. I agree. I see what you're saying there. This one is shit.
Yes. I would not waste any more time on it. Guess A and continue. If this were an exam.
What is the variance of a Bernoulli?
P.
Everything about Bernoulli is written here.
Because the variance of it is
P times 1 minus P.
Okay. I suppose it might be C in my C.
But why would the variance of A times the times square the square root of the variance of A times square root of the variance of B?
Yeah, they don't add up. I'm gonna agree with A then, based on the fact that I can't get the variance thing to add up.
Yeah. Cool. Let's continue.
Actually, logically thinking about it, right? So what's the covariant thing is saying is that if we have some kind of plot error that some plot thing that looks like this, then if we take
invert the B,
invert the B, then it will look something like this. which kind of makes sense, you know. So I'll go.
Like I
I'll go
said,
with A.
intuitively, I would go for A.
The joint density x and y is given by blah blah blah. Compare.
Just check it while it's still fresh in our mind.
Sure. Oh. Wow.
Yeah.
Cool.
Take that.
Okay, nice. We were
Take the
right.
W. Take the W. 15.
Yeah.
Oh. So we have the joint density of x and y given by blah blah blah. Compute p of x greater than 1y. Thank you. This is an easy one.
Am I the only one reading 14 ass?
Hmm.
The dollar signs make it, just becomes ass.
Yeah, fair.
Yeah,
We've
fair.
got 12 ass, we've got 14 ass, we've got a lot of ass.
Yeah. That's the way we
That's
roll
because
around
the
here.
entirety of computer science and engineering is dummy thick.
Yeah.
Fact.
If you
I
are
don't
listening
think
to
the
this, you are dummy thick.
Programmer sucks.
Let's
Would
see.
like to have a
So
word
they're
with
all
you.
between 0 and infinity. So therefore, I can take the integral from 1 to infinity from 0 to 1 of the function minus x e to the power of minus 2y dx dy. No, dy dx. Very important.
Yeah, x from 0 to infinity.
Yeah. So we have this thing is x, which makes sense. This thing is y, which makes sense. Okay. Well, first of all, we can notice that this 2 to the power of minus x is a constant in terms of y, so I can pull that one out up front. Then we just have an e to the power of minus 2y, which when we integrate this becomes
1 over minus 2.
Becomes 1 over minus 2 e to the power of blah 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 from 0 to 1. So then we get this. Recompile. Okay, however, we can take this 1/2 out front, so this just becomes minus, and that will cancel out with this 2.
And we know that
So
other
then,
thing's
yeah,
gonna.
when we fill in 1 here, we get minus e to the power of minus 2. And then from that we subtract what we get when we fill 0 in here, which becomes minus e to the power of 0, which becomes minus 1. So therefore this is our answer so far. And also keep in mind there should be brackets around here.
And it's, yeah. And that you can just
and then
pull out.
also this minus minus becomes a plus.
And from that we should already be able to eliminate quite a few options.
Yeah, but we most likely won't because we're just gonna look at it. And also, since this is a constant multiple, I can just move this one out the front as well. Then we can derive minus x e to the power of minus x. Well, that just becomes minus e to the power of minus x from 1 to infinity.
50.
Yes, this will become. Actually, I should put a thing here. So this will become top minus bottom. The top is infinity, so this is going to be and the bottom is going to be 1. Keep in mind, again, this should be a limit, blah blah blah.
Blah blah blah.
Blah blah blah.
The limit of that is 0.
Yes. So when
who
we look at
cares?
this, minus
still
e to the
have
power
that-
of minus infinity is 0. So this is just going to be minus.
Who's going to stop me?
So this is going to be minus minus e to the power of minus 1. So this is just going to be 1 over e. And we multiply that by this thing. So then we get
C.
fraction of this thing over e. And let's see what looks the most like this.
We'll see.
Yeah. Yeah, let's see. Cool. So that is 15c. I don't know why, but I just really like stuff like 15. It's just, hey, do this, fill this in, You're done.
Yeah.
Okay, let
Nice
n
and chill.
let n be a natural number and x be a discrete random variable with values 1 to n. Which of these following statements is correct? A discrete random variable with values 1 to n. It doesn't say anything about how it's distributed at all.
Yeah.
Well,
How can we give any kind of upper bound for this? Or lower bound? What if they all have a chance of 0? And what if it all has a chance of 1,000,000?
No, well, the probability for each thing has to be between 0 and 1, and the total probability has to be. So whatever you have to integrate it to infinity should from 1 to n should be equal to 1.
Yeah, but we can't. We don't have a function that we can integrate.
Well, you have the left sides, or
So let's just have a look at which one makes most sense.
Hmm. Oh yeah, this one.
I'm gonna be honest. With 5 minutes left, I would probably go 1, 2, 3, 4, 5, 6, 7, 8. That one.
But no, we're no boosty boys.
I know for a fact, since we do not know anything about the random variable, I know for a fact that this is wrong.
Yeah.
And let's see if there's an upper. Okay.
Wait, what's up with that?
What is what? Imagine we have 10 values, right? What is the log of 1 over 10? 1 over 10 squared. That's gonna be 100 to the power of, or sorry, 1 over 100. So that's 10 to the power of -2. So that will be -2.
it's also just you can just put e to like both sides to whatever the log is on here, simplifying it.
I think actually, this one is probably true, since let's see, it's only a natural. Oh wait, natural numbers. Are those only positive integers, right?
Yes.
Okay, so the smallest value here is 1, and the log of 1 is equal to
1 over 1.
So that's 0.
So the log of 1 is 0. So the expected value is at least 0, which makes sense. But we can't upper bound it.
Well,
here, hell, we know this is only positive values. So if we have the log of 1 over n squared,
the expected
if we say 100 n is 100 here, then the expected value of this thing should always be less than -2, which doesn't make much sense.
The expected value will always be less than n at the very least. That's.
Yeah, but that doesn't help us much.
And also, logarithms can logarithms return negative numbers?
Yes.
Yeah, if it's less than 1, it
oh
returns
yeah,
negative
okay.
numbers.
I see. I'm still tempted to just go with this one.
Because
like it's really like almost impossible to give an upper bound on an expectation of something we don't know anything about.
Although, isn't log 1 over n squared? Isn't that log of n to the power -2, which you could change
it's actually
to
0 minus log x.
n. Like so, the right hand is -2 log n.
That becomes.
It has to be greater than -2 times a positive number, which is scuffed.
-2 log
not
n.
gonna lie.
Yeah, so it has to be bigger than a negative number, but the expectation is.
Okay.
Yeah. So it's A.
That's A. I would say A.
Expectation of negative log x.
No, okay. I'm gonna walk you through the thing here. Basically, what we're saying is, this log of 1 over n squared. This is gonna go. This can go up front. As this gonna be the expectation of something is gonna be bigger than or equal to -2 -2 times a positive number.
-2 log n.
Yeah. So yes, it's gonna be greater than or equal to -2 times a negative number, because the expectation is positive.
Well, it doesn't have to be.
Well, okay. But the rest, it makes more sense than the rest.
But because that is expectation of negative log x is what you're seeing there. That is almost always going to be negative.
Hmm.
But hold on.
Because
if
that becomes negative log x.
The highest that expectation can go is log n.
In fact,
or negative log n.
In fact, that will always be negative.
Yes, but the highest, like, the most negative it can be
is log n.
Is
yes.
Negative log n. Which is if you have if x is only n, which is the highest that it can be, it will always be if that was how it was distributed, the so the distribution function or the mass function would just be n. That's it. Go home. It's over. It's n. Then it will still always be the expectation of that is just log 1 over n, and log 1 over n is log negative or negative log n, and negative log n is still greater than negative 2 log n, because that's because that's more negative. So a is always true.
I can agree with that logic. I support it.
Great. Let's see us have it wrong, and I'm gonna be really, really fucking. I'm gonna
No,
laugh.
it's correct.
Right now,
Okay, let's see what we all have correct.
20 seconds later.
I mean, we also started late, so.
So we started out 1D, correct. 2E, correct. 3D, correct. 4B, correct. 5C, correct. 6B, correct.
I think I've been loading curls
wait, where?
for
7C, correct.
now.
8B, correct.
9E.
9F, correct.
Oh.
Nope, 9F, incorrect. We'll look it up.
I
10F,
feel like that
correct.
was the one where we were like, fuck off.
11C, correct. 12A, correct. 13E, correct. 14A, correct. 15C. Okay, yeah.
Okay.
So everything except for 9.
Dear God, I think I modded
okay.
fuck off for my computer.
And that's a shit question. All
right, I'll take the W.
W.
Yes. Can someone explain the last question again? I didn't really
Sure. I can if you want. So say so because x can only take values from 1 to n, yes? The the expectation of log 1 over x is gonna be 0 to log 1 over n, which is when the discrete random variable only gives 1, and when the discrete random variable only gives n.
Yeah.
So it's going to range between that. So you could write that as log 1 over n, because 0 is always going to be larger than the right hand side. We'll talk about that later. But so the highest value, like the value that's closest to log 1 over n squared, is the log 1 over n. And because you can transform log 1 over n into negative log n, and log 1 over n squared into negative 2 log n, you will see that it ranges from 0 is greater than negative 2 log n to negative log n is greater than negative 2 log n, which both are just always correct. Does that make sense?
Yeah, I'm just trying to write this all down because it's a lot of.
Yeah, understandable. I would write it down, but I'm not Jure. And the thing is, it's either A or B, because like, one of the two has to be correct. I mean, I guess it could also just be that it's scattered among all of them.
That first statement, so you're saying that e of x is greater than log of 1, less than log of 1 over n. Or did I get that
now
wrong?
I'm saying that the e of x, e of log 1 over x, is at the most, because x can only take values up to n. So the highest that E log 1 over x is going to be. Or, well, in this case, the lowest, because it's a negative number, but whatever. The lowest it will ever be is when the random variable only spits out n. So the mass function is literally nothing except for n.
And then that's going to be log of.
Yeah, then the expectation. So if you have if it's always n, then the expectation is log 1 over n times 1. So just log 1 over n, you know?
Oh, yeah, okay, I see it now.
Yeah.
I got the inequalities messed up because of the larger and lower.
Yeah. And because it's negative, yeah. Okay, time to take a break, and tomorrow clean my entire room because of the fucking subject. I swear, I really
No. Tomorrow we have SQT.
Wait,
That's the
tomorrow
day
first.
after.
Fuck!
Yeah, the day after that we have PTS.
Okay, people, do not forget to NQ. That's q.tf.nl. Everyone with EFA, do not forget to actually upload your proof of enrollment to EFA. Otherwise, they'll start charging you, and fuck the banks. Yeah, that's all.
Proof of enrollment to where?
If you're
ING event.
EFA and you go to main.eg.nl, you will see that they're actually cons, and because actually, do you have Duo? Do you get money from Omo Duo?
No.
Okay, if you do not get money
Wait.
from Omo Duo, at
Wait
this
a
point,
second.
they will
Meanwhile, I will
end the recording.
say thank you everybody for watching. If you have any questions, send me a message on Discord. Good luck with your exams tomorrow, and 2 days perhaps.